Have you done this before?
No,
So I guess we're your guinea pigs.
you guys are the guinea pigs for Liebert 101. This was born out of that partnership with Emerson, which I just heard Liebert's being sold. Emerson's selling them off to somebody. I don't know if you guys heard that. I don't know what it's going to mean, but yeah, anyway, kind of different. But I know talking to Sean and talking to some of the other guys, Liebert's were kind of something that everybody was struggling with and wanted some schooling on. And I thought the shop was going to send people to Liebert school, but they never did. So they asked me to put something together so that at least you guys kind of had some good information to go on. And that's where this came out of. So this was, I put this together with the help of some of the foremen, asked for some input and some critiquing. And the idea of this was it is a Liebert 101. It is basics. So for you guys that already work on Lieberts quite a bit, there'll probably be some redundant information, but hopefully you get something out of it. And then this is you guys are the tester group, so I'll send out a survey afterwards, and anything that you guys have for suggestions or whatever, I mean, please feel free to be honest about it and put in whatever you want. And then also, if there's more, we can do a 201 or whatever we want to do. So it's our training, so whatever you guys want. This presentation, so you're all probably familiar with PowerPoint. This is called Sway. It's just a new product from Microsoft. It was kind of my first experience with it. But I'm going to send out at the end, maybe not today, but at least by tomorrow morning, I'll show you guys how to access this so you guys can have this. There's stuff in here that I'll skip over. There's some videos, there's some things I put in there that, you know, you're not going to remember all this, but by having this presentation, it looks actually better on the iPads than it does on the PC. So you can have it, you can look through it, you can refer to it. There's passwords, there's setup information, there's pressures, there's temperatures for different types of units and refrigerant. So you can refer to that in the future. So don't feel like you have to write everything down that's in this. It's you'll have it for later. And then also we'll go through within Dropbox, which I'll show you again. You can get to through your iPad the PDF Expert. There's a new folder called Service University, and on that there's manuals, there's unit information. This presentation's on there. There's 50, I think, almost 60 different Liebert manuals on that now. So if you go out to a site, you need a manual on something, you can go to that Dropbox and you can find the manual rather than trying to Google it. I mean, you can, a lot of the information you can Google, but a lot of the older stuff, the archive material is getting harder to find. So if you go out on something with really old controls, this might be your only source to get it. So that might be useful to you. I'm sure it would be. Yeah. So we'll go through how a data center works. Not everybody really understands what data centers do. So there's a quick video we're going to watch. It's geared towards being simple, so you might laugh at it, but nope. There's some good information, and once again, it's kind of geared towards guys that haven't done a lot of work in data centers or worked on Lieberts. So that'll hopefully kind of help you understand what data centers do and why we have them. All right, hopefully that doesn't happen too much. And then we'll get into kind of how data center cooling is different than like comfort cooling, because they are two different animals. The three units that we're going to cover are Challengers, Deluxe System 3s, and DSs. There are a lot other units out there made by Liebert, but those are the three most common that most people see. Within the Dropbox information, there are different Lieberts. There's the extreme densities, there's the ITRs, there's the old SM controls. There's a lot of stuff that we're not going to cover here, but that is available on that Dropbox Service University link that I'll show you how to get. But that's what we're going to focus on, those three. We'll go through the controls types, the most common that we see. Proper operation, maintenance, common alarms, common Liebert issues, how how to get to their tech support. So you guys have a number. Most people know it, but this will be something. And then we'll finish it up with the Service University Dropbox. So first of all, we're going to watch this quick little video.
Drawing out the back, the naked side scrap.
Sweet audio.
Hello and welcome to the Naked Science Scrapbook with the Naked Scientist. This time we're answering the question, what does the data center do? Everyone needs to back up their computer data, including things like documents, customer details and financial information, to keep it safe from theft, fire or being accidentally deleted. And most small businesses, charities and other organisations also need an internet connection for their website and emails, so they normally store their data on a single server on the premises. This is essentially a specialised computer the size of 2 pizza boxes connected to the business's local network and usually also the internet. It contains a set of hard disks that store data that can be sent out through the network to other computers locally and to people visiting the business website via the internet. But as organisations grow bigger, demand for their products grows. Staff need to store more data and the website becomes more popular. This all means that they inevitably end up needing more servers. And eventually they have to build up an entirely separate server room just to house them all. But this isn't straightforward to maintain. For a start, lots of servers create lots of heat, so they need to be kept cool, otherwise they can fail catastrophically. And providing this level of cooling using traditional air conditioning units can be very expensive. In fact, current estimates suggest that about 1% of the energy consumed by the entire world each year and 5% of Europe's annual energy bill is spent just on cooling computers. Server facilities also need to be maintained around the clock by IT professionals to ensure that they run reliably. So together these constraints can become a serious financial and logistical headache. Not to mention security risk. Keeping business critical servers in-house is rather like a bank keeping its cash in a shed in the car park. But rather than trying to solve these problems themselves, many organisations instead now choose to move all of their servers out of their own buildings and into a specialist facility called a data centre. This is a secure, computer-friendly environment that's maintained around the clock by IT specialists, mechanical experts and electrical engineers, and kept at just the right temperature to ensure that the servers supported inside perform at their best. Crucially, data centres are also equipped with their own backup, uninterruptible power supplies, usually in the form of large batteries and a powerful generator, so even if there's a mains electricity failure, the servers and the organisations they support can keep on running. And because this facility or location is shared by many organisations at once, it's known as co-location. A data floor looks a bit like this. The servers are held in locked cabinets or racks. Data center clients rent as many racks as they need, according to the amount of processing power, storage space, and bandwidth that they use. The R's between the racks are alternately hot, carrying the waste heat away from the servers, and cold, fed by fresh, cooled air that's driven through the racks to keep the servers at a constant, computer-friendly temperature. Traditionally, aircon units, similar to the ones used in cars and homes, have been used to store the cold air needed to keep the server rooms cold. But these are very costly to run, meaning that often as much electricity is consumed just keeping a facility cool as is used on running the servers themselves. In fact, for this reason, the global data center industry accounts for nearly as much carbon dioxide production as the airline industry every year. More recently, though, the introduction of newer eco-friendly cooling techniques has enabled data centers to reduce the amount of electricity and carbon used in cooling by up to 90%, helping them keep costs down for their clients. The new system uses the same science that keeps you cool when you exercise. While you sweat and the evaporation of the sweat carries away heat from your skin, these cooling units evaporate water from wetted filters, dropping the temperature of the passing air. So if you've already got a computer room with all your servers in it, why would you need a data center? For some businesses, popping their servers in a data center might not be necessary. But organizations are increasingly doing the sums and asking, how much electricity and floor space will we save if we keep all our servers in one location? How much will it cost if we need to expand or reduce our current IT infrastructure in the future? And what would be the cost to the company if we lost our servers to a power cut, theft, fire or flood? If the answer to any of the above is a lot, then a data center might be a better option. That's it for this time. This video was produced in association with 4D Data Center.
Does anybody not have a data center that they work in? Everybody's worked in data centers. They're familiar with how they work and protocols. I know up in Seattle we have a lot of people that they've never stepped foot in a data center. And so you talk to them about it, they don't know about co-location, they don't understand hot aisle, cold aisle, they don't understand raised floor cooling. That's something you guys all have. You guys are all used to that. Have you guys had a lot of the new data centers that have the Munchers pads with the, like she was talking, when instead of using mechanical cooling or DX, they use the water pads?
We used to take care of, or I used to take care of Adobe, and that was the only one they all used, Munchers. Unless where? Do they?
Yeah, they're becoming a lot more common.
They got them for their electrodes.
Yeah. They
Is
burn
Munchers the
through.
only spot you can find the salt cooler pads?
That's the only one I know of, but I think that Link Tolliver up in Seattle, one of our small repairs estimators, had found another source than Munchers. But
Like 3 weeks within 5 days of shipping.
the problem I think that we had, the Munchers pads are UL rated for like data center usage, whereas the generic ones aren't UL rated. So depending on your customer, they may or may not work.
By generic, you talking about the straw, or are you talking about the blue pads?
It's the pads.
Yeah.
It's like a straw-colored pad. They're kind of fibrous. You can't see through them. They're not stringy, but they're like the ones that I've seen. They're generally like 12 inches wide.
Oh, like a honeycomb.
Yeah, about yay tall, and then they're like they can be like 18 inches deep, something like that.
Okay.
And then they're kind of rigid, and then when they get wet, they look like they're going to collapse, but they don't. And they run.
Kind of wafer-like.
Yeah.
If you leave them in layers.
Yeah, they're weird looking. But yeah, they're becoming more common. So with data centers, and I probably won't read through all this, but with comfort cooling, like we're sitting in here, 30% of your cooling or more is in the form of latent heat removal. You're removing moisture. Humans put off moisture, and you got to remove it. Data center cooling is different. It's all dry heat, like it says in the down here. It's like a hair dryer. So that's why Lieberts are specialized. That's why if you walk into a data center, you don't see a bunch of train split systems generally. There are some cheaper ones. We've all seen Climate Masters and stuff in data centers, small IDF closets. But it's a big waste of money, and that's something to know. And there's actually kind of a formula here that says it takes like you can get, what the hell does it say? Something about 4 tons of data center cooling from a unit is equal to like 6 tons with a standard unit. So there's a big energy savings using Liebert or Data Air or something that's made to do sensible cooling. And that also, one thing you'll notice with a lot of data center units, they run a lot more air through them than a standard unit. So your split tends to be a little bit lower. So keep that in mind when you're out doing maintenance. ASHRAE, they set standards for data center cooling. And this is one of those slides that'll look better on your iPad. But this is what ASHRAE says that a data center should be at for temperature. And if you look at it, we've all probably ran into customers that want their data center to be 65 degrees and 50% humidity. They think it needs to be cold and like perfect, but it's not really the case. And this is kind of some backup. I'd always look for some backup when trying to talk to customers about raising that up, because there's no reason to run data centers that cold. And this is kind of a neat little chart, because if you look at it, right here is 60 to 65 degrees. So we're about 68 degrees here. If you're running at 68 degrees, you can run that between 45% humidity and about 90% humidity without causing problems like where you get into condensation. Same with the other side. You can run it up to about 85 degrees, and we're about 25% humidity, all the way up to about 60% humidity. So it's kind of a neat little window there. If you ever had a customer that said, hey, what's a good temperature, or what should I be running it at? This is something you could refer to and say, hey, well, this is the ASHRAE standard, and show them this little box, because until I saw this and actually knew that there was a standard for that, I always kind of guessed and said, well, I don't know, 72 degrees and 45%. But here's some backup for, for what you're trying to sell. So what makes a good computer room unit? Running 24/7, removing high amount of sensible cooling, maintaining tight temperature control, monitoring its own operation, reporting its alarms, and be serviceable. We've all walked into kind of older data centers that, I wouldn't call them a data center, but they're like some room that's been converted into an IDF closet. They got an old crappy split system sitting in there, and the customer's pissed because the thing never works right. Well, it's because they didn't spend the money to put something good in there. So that's what makes a good unit, is being serviceable. You look at Lieberts that are 40 years old, you can still get parts for them, and that's what makes them quality. You can still get the stuff. So the first thing, Challenger. We're going to get into the Challengers. You guys have any of these or many of these? About the size of a refrigerator, about yay tall,
Just
yay
worked
wide.
on 2 of those on Friday.
Been made for a long time.
Wasn't there a Challenger series for ceiling install also?
There's the mini mates, but I don't know about a Challenger in the ceiling. There could be. I've never seen one, but it's certainly possible. Challengers come in upflow and downflow. One easy way to tell the difference is generally by looking at the front. An upflow is going to have a grill in the front. Air goes in the front, comes out the top. One of the problems I had putting this together is finding good pictures. Like, I thought I could just go on Google and find a bunch of data center pictures. It's not the case. So I had some guys send me some stuff. So we had some customers sign off on saying that, yeah, you can take pictures in my data center, but you'll find as we get into the newer equipment, the pictures get better. There's just more stuff online. But on these Challengers, this would be a downflow. The filter would be on the top, pulls air in from the top, discharges it to the bottom. That's for like a raised floor. The Challenger upflows, generally they have a grill in the front. Air comes in the front, goes through a filter. Here it is opened up. Sometimes they'll have a back return. So you walk up and it does have the front panel, but there's no slots. That'd be a rear return.
When it's not in the room, it's cooling.
Mm-hmm.
Typically.
Yep. You can see like this one here. It's ducted through the rear. That's the return. Cools it, blows it up through the top, pushes it back out. There's kind of a newer Challenger, just opened up. You can see they're all kind of built the same. If it's a compressorized unit, compressor's on the bottom. If there's a condensate pump, it's generally on the left. This would be connected to a building or a water supply. Has the helical water coil in it. That humidifier, we're going to get into humidifiers specifically and different sources of cooling and humidification here in a little bit. Generally on the Challengers, they're one-stage cooling. They have one compressor for the mechanical. According to this, there is optional 2 stages of mechanical with a Challenger. It's a split coil, so they'll split it into 2 parts. It's your standard A coil. I've never seen one. Has anybody seen a split coil Challenger like that? I think it energizes the hot gas is what it'd have to be, but I've never seen that. Heating, generally you have the 2 stages of reheat. SCR is like, I don't know if you guys have seen it, but I've never seen one with the SCR, but it's instead of just being on and off, it's intermittent. It's like a duct heater in a way where they can vary the amount of amp draw through it. That's Liebert's type, that's what they call it, the SCR heating. Humidification, generally they have the infrared. I think we're all probably familiar with the infrared pans. That's what this guy has in it here. I've never seen one with a steam generating can in a Challenger. I don't know where you
think
put
it's
it.
big enough. Yeah.
Well, according to Liebert, it's an option.
Yeah,
I've
it
never-
sits behind right behind actually the condensate pump sits further back.
Oh, it sits
And
right in the
sits
front?
there.
Okay.
Yeah, it's
Or on the
okay.
left, because that left panel comes off too. That's probably where it is.
Yeah, that's what it'd have to be. I've never seen one with it. We're going to get into those humidifiers quite a bit. And then dehu, that's just running heat and cooling at the same time. We don't use a lot of dehumidification up here. If you have kind of an anal customer, they may want really tight humidity tolerances, but it's not all that common. Let's see if we can enlarge this a little bit. Right. So with any of the Challengers or any of the Lieberts, there's several different ways that you can get rid of the heat. At least in my world, the most common was this, where you had water coming in from an outside source, whether that's a cooling tower, or you'll have a unit up on the top with glycol pumps or water pumps and a dry cooler. And on those, your water's running through a water regulating valve. This is hooked up to the discharge of the compressor, and it varies the water flow through this water heat exchanger here. Some of them will have this three-way valve, so the water's constantly flowing. A lot of times if you have that, you'll have a pressure differential switch or a paddle switch, so the unit can alarm if it loses water flow. Is this generally what you guys have where they're water cooled? Or do you normally see like the air cooled ones? Air? Yeah, the air cooled ones. So this would be basically the same setup, but this is where you have like the Liebert condenser up on the roof. So it's a self-contained water cooled unit, and it has these pumps. It'll have one or two pumps up here, and then it'll have a coil, and then it has this expansion tank sitting up on the side. They're pretty common on smaller buildings, 2- and 3-story buildings. And then this one you can see has the Econa coil. These are pretty popular. These sit in the unit, and then if the water that's going up to the unit for the dry cooler, if this is suitable for cooling, it runs water through this Econa coil for cooling. And we'll get into that with the controls quite a bit more and how it makes that determination.
It's really big now on all the newer stuff. They're almost all put.
Yeah, you have to have it for energy code. You have to have a way to get some free cooling out of them. And then this would be your air cooled type. So on this one, you're not using water. You're pumping refrigerant straight up to that outdoor coil. And then from that, you'd either have fan cycling control. There's also a thing called a Lee Temp, which we'll get into a little bit here in a few minutes. If you've ever seen the Lee Temp, it has to do with a receiver, a heated receiver. They're kind of funky. And then chilled water systems, those are the simplest. Those are the best to have on a maintenance. There's nothing to them. Those you have chilled water coming in from the building. Just like on the other ones, this would be from the building side. If it's a three-way, you have chilled water coming in, goes through a three-way valve and back out, and you have a flow switch. That way, if you lose flow, the unit can alarm. Somebody turns off a valve, a pump turns off, whatever. If you have a two-way, then you don't have to switch. Liebert does make a special switch. This isn't just it's generally not just like a Johnson Controls or one of the, like a boiler paddle switch. It's a little more sensitive. Liebert sells them. They have gold-plated contacts in them. I don't really know why you'd have to have the gold-plated contacts, but I do know that that's what they tout them as if you buy them through Liebert. So if you have one that's acting up and it's not a Liebert factory switch, it might be worth keeping that in mind that they do sell that one.
Well, the gold contacts are the best conductivity, right?
Oh yeah.
So that's
I think what it is because they send down the 5 volts from the control board, and that's what goes through that switch. So if you put in a standard like one of the McDonnell Miller or the Johnson Controls paddle switches, it may have too much resistance to that 5 volts. That's certainly a possibility. So the Deluxe System 3, we've all probably seen these. These are, to me, they were always the most common units. Is this kind of what you guys see a lot of? They've been around
got a ton of these.
Integra? Yeah, they've been around like 40 years. These ones, this is kind of a standard breakdown of the model, serial chart. Any of the manuals will have this, tell you what the, upflow, downflow, if it has an Econa coil, the DE. Feel free to grab food if you want, Brett.
okay.
There's lots of burritos back there. There's a couple different arrangements as far as the upflows on a Deluxe System 3. You can have the standalone, just pull it in through the bottom, blow it out the top, the ducted or remote ducted with a reverse return. So just like the Challenger, there's a couple different options there. And on the Challengers, they're always built the same. The compressors, if there's compressors, they're on the left, fans on the right. We've had guys before that, and part of this class was born out of guys walking up to units and not knowing kind of where components are. And we've had guys take, while the unit's running, take the panel off the right-hand side, and then it trips that overload in the fan, and then the thing goes down, and somebody's all upset. So that's something to always keep in mind with these Deluxe System 3s. Left side's the compressor, right side's the fan.
You usually hear those things going.
Yeah.
Unless they're not running.
On the upflows, the filters are down in the front. You can generally access them from either side. If it's running, you get it from the left side, and I got some decent pictures to kind of show how that's done. You can get to the left side while it's running, but it's kind of a bitch to slide these things out with that air pressure. On the downflows, so that would be your raised floor, just pulling in air from the top. Sometimes I've been seeing more popular now where they'll put like a hood on the top of that, and they'll use these false ceilings as like a kind of a return air plenum, so that servers mounted across the room, that air can kind of go up into the plenum up here, and then it sucks it back out. Kind of a neat way of doing it. Most Lieberts have the two Carlisle 060s, standard compressor. You've probably seen them. They'll have a suction unloader built into one head. So your 4 stages on that would be your lead compressor is reduced, so one compressor unloaded, and then both compressors unloaded, and then one compressor fully loaded with the other one at leg, and then both compressors fully loaded. And we'll get into that some more with controls. Heating, kind of the same thing as like the Challenger we talked about. You can have the standard 3 stages of electric reheat. You can have the SCR heat, which is that variable heat resistance. You can get steam coils. I've never seen a steam coil in a Liebert, but apparently it's an option. Same infrared type. The steam grid is optional if you have a steam plant in a building. They'll put a steam grid in there. And then there's the humidifier, the canisters. And then DU, heat and cooling at the same time. These are just showing a couple different ways of, this one just kind of showing you the compressors are on the left, and then it has those shell and tube heat exchangers. I'm sure you guys have seen those. This is kind of a little different, little better picture. Those heat exchangers here, the water comes in, floods around the tubes, takes the heat away. You guys ever have to clean these? Do you have any buildings with dirty water supplies that you have to clean those condenser barrels? No. You can pop the ends of these things off. I mean, obviously you have to valve them off, but you can pop these end bells off just like a chiller barrel. Run a tube routing machine down and clean those tubes out without taking the refrigerant out. I've done a few of them where you just a dirty lube, but it does happen from time to time. Kind of the same different scenario. Here's a good picture of those compressors, the way that they mount. This is quite a bit smaller unit, just one fan sitting in the middle. That'd be a downflow because the fan's down at the bottom, upflow, the fan's up at the top. The piping's basically the same as the Challengers. This guy here, that'd be an air-cooled where you're pumping the refrigerant up to the top. And this would be the lead temp type where there's actually a receiver that sits up the top. Have you guys seen the lead temp type receivers? It looks like it's just basically a condenser unit up top. Obviously the compressor's not in it, but it's got a big receiver with heating pads in the bottom so that it can run down to about negative 30 degrees. It's kind of why they're not all that common up around here because we don't get that cold. But it is something to keep in mind. I put some instructions in here in a little bit on those lead temp receivers. They have sight glasses. There's one down at the bottom and then there's one in the middle, and they have little white balls in them. And depending on the outside air temperature, those balls float at different temperatures. So if you walk up to it, you would think that if the bottom one's floating, but the top one's not, maybe you're low on gas, but it depends on outside air temperature. And there's some instructions here how to do that. I'd mentioned that you can change filters from one end while the thing's running. If you're on a downflow unit and it does not have the econocoil, you can see here. So this is a picture looking at it from the compressor end. You can see how that filter sits right there. And you could slide those filters out without taking that far end off. But if you have that econocoil, you can see how that piping. And it's kind of difficult to see here, but there's a
valve right in the way.
yeah, you got that. Now you have that valve there. It's another indicator that you have that econocoil in it too. And then same thing with the other side. You can see here. You can see where those filters sit. So that filter's right here without the econocoil, and then over here, that's the econocoil sitting there. So when the airflow is coming down, that's a downflow. The air goes through that econocoil. The idea being if the water in the building loop is cool enough, it can pre-cool that air before it goes to the DX coil. That's what that econocoil is doing. And that's the same with like this guy here. So this is an upflow coil. The air's coming, you can see the filter here. The air's coming up. This is the water coil portion here. This is the econocoil. And then this is the DX coil on the outside. So you can see how that air is going through that water coil, pre-cools it, and then it goes into the DX. One thing that you'll have with these are low temperature freeze stats that are on the DX coil. If this water coil is cold enough, it'll cool that water down to the point that you'll start getting ice on those DX coils. And something that I found out kind of the hard way is that when these things trip, it gives you a low suction pressure. So if you're having a low suction pressure alarm, there's a good chance that it's from those low temperature stats. And when we get into the wiring diagram, I can kind of show you how that's in there. Here's a little bit of its operation there. At lower fluid temperatures, the second coil acts as the main cooling. The valve opens to match the room load. And as that return air temperature comes up and the need for more cooling is there, it'll start to bring on the compressors. And then this is the simplest one of all, the chilled water Deluxe System 3s. Just like the Challenger, the only thing you have is a three-way valve with a switch, or a two-way valve and a coil. No compressors, no nothing. You can see how empty this control panel is. And this one has heaters. You can see the heaters here, but there's no compressor contactors, nothing there. Those are dead simple. You guys have any DS units? A little bit newer ones? They're kind of a darker gray generally.
There's one at United States.
They're nice. Liebert stayed with the same type of setup. Compressors on the left, the fans on the right. 8 to 30 tons, same configuration, upflow, downflow. That's in there for your reference. So when you have this, you can look through it in the future, kind of help identify. They have went to kilowatt instead of tonnage now. So whereas the old ones, you can see they kind of still give you a breakdown there though. So 28 tons. I think Mitsubishi and LG are doing the same thing. Everything's kind of going metric. Liebert's went to 407C. They do have 410A as an option. It's not on this chart, but 407C is going away too. So is 410A. Both of those just got put on the EPA list along with 134A. So get ready for a bunch of changes there.
Not gonna be any refrigerants left.
Well, it's going to be propane, ammonia, and CO2. Yeah, propane's getting popular. It's kind of weird to think about running
When I
propane.
went through tech school, they had a refrigerator running off propane.
You can
Or these do.
You can go to Costco right now and you can get a freezer that's got propane as a refrigerant.
Canada's been using it for a long time.
Yeah,
Europe.
yeah. Europe has. Europe banned 134A and 410A quite a while ago.
That's where all the CO2 systems are coming from.
Where what?
That's where all the CO2 systems are coming from.
Yeah, I believe it. I believe it. Same basic setup. One thing that's kind of neat about these DS units this is one of the new things with Liebert. They have these DC drive fans, and these things when they ship, they're up inside the unit. And you can duct them straight out the back, straight out the front. I've never seen one out the front. I don't know how you get to the control panel with it, but then you can drop them down in the floor. There's a little crank deal. You drop them down on the floor, and what that does is it gets rid of this. It gets rid of the need for having to have a scoop, so you don't have all that pressure drop where you push it down and through. And then these can act as a backdraft damper. Because generally, you have Lieberts, if you're in a big data center, you'll have Lieberts stacked up against the wall, and then they're in a raised floor. And if you have one that's off, you got air blowing through the ones that are off, because all the others are pressurizing that floor. And these things have a backdraft mode, so they'll sit and run at like 8% or something.
Makes it a pain in the ass to change out belts on that.
Well, they're direct drive.
I meant on with the levers.
Oh, yeah.
With it back, blowing back through.
Oh, yeah.
Take a screwdriver in there or something to
Keep
keep it
something in there.
Yeah. Keep it from cutting your fingers off like trying to get the belt.
Yeah. Well, that's the same basic thing. Upflow, downflow. That's just the new invention now, is having those DC fans. And they make conversion kits. You can take any of those older Deluxe System 3s and put these fans in. So I know that we've had some guys do them up north. Have you guys done any conversion kits or heard of any of them down here? They basically swap out the control. I'll have another better picture of it in a minute, but they'll, oops, what did I just hit?
Aircooled was thinking about that.
Doing the DC fans? Yeah, apparently there's a lot of incentives to do it, power-wise. There we go. We're back.
Yeah, they're afraid to spend any money. They keep blowing smoke up our ass.
Projector keeps losing it.
Yeah, we might as well work for
Right prices.
All right, we're going to get into control types. There's 4 different types of controls we're going to cover. It's the touch screen, which these are pretty slick. I've only seen a couple of these, so I'm not really well versed in them.
They lock you out in a matter of minutes.
So yeah, you guys may know more about them than I do.
Password.
5150, isn't it?
No, it's 5010.
5010.
Yeah, I put the passwords in here for you. I liked these large icons. I probably had the most experience with those. And then there's the
I like the
AG.
interface for it better.
The what?
The interface, they have an interface that ties into that, so you can put all of them together.
Oh
And
yeah.
you only have to go to one.
Yeah, and you can scroll through them.
Mhm.
Yeah.
I had to replace one of those because they would touch it in one corner of the screen and it would react somewhere else.
One of these touch screens?
Yeah.
Really? And they just sent you a new one?
Yeah, I picked it up from one of the guys in the back. It was out at Nike. He was replacing it because it was, I don't know if the guy was overly sensitive to what it was doing,
But it was acting fine, it just, you touch it and
yeah,
just
it took a
freak
while of touching it in order for it to respond.
Yeah.
One thing I was curious about, now that we're on this, you got a sec?
Yeah.
They come with a clear plastic cover over it. That's the way it was shipped.
Yeah.
And the ones that were there had that clear plastic cover still on it.
Yeah.
I was wondering if that was part of the problem, if having that clear screen, that clear cover over the screen was interfering with the responding to the touch.
Could be, it's no different than an iPad.
Yeah.
So like a screen protector, or just was it just there for
peel off.
shipping?
You could put it back on. It was really easy to take off and put on. It would re-stick, but I wasn't sure if it was supposed to stay on or come off. And the other ones had them still on that were there in the space, so I just left it on.
The only one that I've worked on, the only site, they were removed. They didn't have the plastic on there. I don't know.
They say those like when electronics come shipped, they have the clear film to protect it, and then you're supposed to remove it because it'll keep some of the heat inside.
Yeah, it hurts the screen.
Yeah, so it'll overheat that component.
Yeah, I've heard
Peel
that
that
too.
plastic off, it'll let the air hit it.
You're gonna have to go back and put all another one.
I'm afraid to go back
Talk to
there.
your foreman about that.
He's right behind you.
Probably get punched in the back of the head.
One thing to note, these two they don't make these anymore. And the boards that go with them, they're the same board, but they don't make them anymore. There's still a stock of them, but they're not being supported.
No, but you can use you can now interface them with the new screen.
Well, yeah, you can install this with the new board or this. These two share the same board.
Yeah.
And this, I think, is done, this large icon.
Is that right?
Yeah. That was a short
That
lived.
was very short.
It was like,
Couple of years.
well, no, it was like 8 years.
It didn't last that long.
It was about 8 years, and then they went to the touchscreen. But they share the same board, so at least if you have the large icon, if the board fails, at least you got backup. So, but that's something to keep in mind if you have a customer with this the AM or this AG, and they have a board fail, which they have a tendency to little triacs on them fail, like for the humidifier makeup or the heaters or whatever. They're gonna have to upgrade. So, last I knew, there was a 6-week waiting list to get a new board, like an upgrade kit. So, something to mention to customers if they're that concerned about it.
What's the, do you know like a cost on those? How much does it just run?
Yeah, I think they're like, the cost is about $3,000 to the customer for a kit, and then plus the labor to do it. And that's a board, that's the display, and then it depends on how old the unit is that you're replacing. Because if you can take a 30-year-old Liebert and put the newest control on it, but then you have to add humidifier, float, pressure sensors, transducers. I mean, all sorts of stuff. So that'd probably be more expensive.
It gets like an adapter for it to fit in.
Yeah, I think you just cut the front panel.
Shit.
Yeah, you just cut it out a little bit.
Brush up on
I
my.
think it fits over it. I've got one where they did it. It was done previously.
Yeah.
And it had that. The
I-
old one should have been the one on the bottom left, and it's the large icon display now.
Oh, so that one, they didn't even have to cut it? They just put it in
I
there?
just put it in.
Yeah.
Slid in there.
I know, I did from this one to this one, and it just fit right in there, but you can look at them and they look physically the same. But I haven't done I didn't upgrade any to the large icons. It makes sense if they did. I mean, they look like they're
It
about the
mounts
same
over the
size.
hole. It mounts over the hole, so it's on the outside.
Oh.
It's not flush.
Well, except, see, the one thing about these that's nice is they drop out the back. So you open up that dead front panel, or the decorative panel, you hit a little thing, and then this pops out the bottom, and it's got 6 foot of cable, so you can sit on a bucket and mess around with it. That was what's really nice about those. I don't know if these drop out the back. I don't remember.
The front.
They come out the
There's
front.
4 anchors on the back to hold it in, and then you just pop it off the front.
Oh, that's kind of cool.
Plastic one.
So if you drop it, you don't scratch it. So yeah, the AM, a lot of people call these like a 4-line display or a green screen. They're not made anymore, but they're pretty simple. I put in kind of a flow chart for that. So you guys, if you're on site, you pull up this presentation, which, like I said, you'll have access to. There's an easy way to navigate through it. There's only like 4 buttons on there, so there's not a lot going on. But we'll get into resetting alarms here in a second.
1, 2, 3, 3, 2, 1.
Yeah, those are the factory defaults. So if you go out to one and you go to change set points, generally your set points are that's your password is 1, 2, 3, and then anything advanced like alarms or whatever 3, 2, 1. If you want to disable, let's see here. It's weird how that's showing up like that. There we go. It's kind of hard to see in this picture. It'll look better on your iPad, but right here, those are the dip switches, 1 through 8. That number 8 dip switch disables your password. So if you get a customer that got fancy with it and changed them all to 911 or whatever, you just flip that number 8 dip switch and you can bypass all those passwords and just make it so it's not required at all.
That's good to know.
Yeah. And then something else a lot of guys don't know about is right next to this big connector here, there's a contrast display wheel, and that changes the contrast on the screen on the front. So if you walk up to one, it's like kind of really like hard to read, like almost looks washed out or faded. You can adjust that with that little wheel right there. That'll change. Same thing too if you get one that's really dark. A lot of times somebody's bumped it. They've turned that wheel too far. or it's just gotten old, you can kind of correct it, get it back to where you can see it again. But you'll notice, like, if you look at the, let's see, does this one have it? I don't see the dip switches on this one. We'll look at the next one, but you'll see it. Oh, here it is right here, dip switches. So if you were to if you wanted like those dip switches, and this would be more for probably more advanced Liebert, but they control like what the Liebert's doing. Like, is it chilled water? Is it DX? Is it 4-step or 2-step cooling? What type of coil does it have, or conic coil, or whatever? You can see those settings by if you were to navigate through here to show dip switches. So if you were to start at the top, up here, you'd go main menu, setup, set point, setup system, and then down to show dip switches. You can see that, but you'll notice here there is no number 8. So that's kind of like that hidden dip switch. That's your password one. I don't even think it says it in the manual. Like, they don't really tout it, as it's kind of a security thing for Liebert. On the AMs, when an alarm comes in, and this is pretty much the same for the larger displays too. If it's like a temperature alarm, it'll self-correct if the temperature comes back into range. If it's something that like a high head pressure, it'll stay there until you reset the high head pressure. And there's a little section here that kind of walks you through how to reset alarms. So you don't have to remember it, but you'll have it in the future. The 3 that will reset automatically, but it takes 90 minutes, is this loss of power, low suction pressure, and short cycle. So this is a common one in data centers, because what they'll do is once a month they'll go to generator power, or they'll go to UPS, and then they'll get these loss of power alarms, and they'll call you up and say, hey, how come I got this loss of power alarm? So you can either wait 90 minutes like it says, or you can shut the whole thing down, and that'll generally clear it.
No, generate code again though, won't it?
If you do a proper shutdown. So a proper shutdown, which it does say in here somewhere, a proper shutdown is to hit that on off, let the compressors pump down, and then once it pumps down, the fan turns off, then you kill power. That's what's called a proper shutdown on them. If you just kill power while they're running, then that's what triggers the loss of power alarm. I put a little box in here to show you some kind of average settings. So if you were to walk into one blind, you really didn't have any idea where you should be setting stuff or whatever. Like, once again, I mean, this is Liebert 101, so it's supposed to be basic. 72 degrees. Deadband is called sensitivity in Liebert speak. So some people, I know it's kind of hard to read from where you're at, but some people wonder what sensitivity is. That's all it is. It's just deadband. And then if we get into a more advanced Liebert class, we can talk about like proportional versus the integral and the intelligent type controls. They kind of play into it a little bit different, but generally a 2-degree deadband is what you're looking for on a Liebert. One thing to keep
in the lean world, you know, I've got a couple of buildings doing that, and they actually had me set it at 7.
really.
And they wanted it 42 for humidity for the 7.
What was their reasoning?
Basically not keeping the unit running, not allowing that long sway, doesn't run it. So, for instance, humidity actually was probably the biggest one. Actually, you're not adding load if you're not adding humidity.
Yeah, so what you'd end up doing.
We had a problem with that on Friday. We were getting a short cycle alarm. It was short cycling because it counts every time it goes into dehumidify and towards your compressor on times. So
So we'll just, because this is a standard like proportional band, so we'll say that this is cooling. So if you were to take, let's see here, let me just do the math on it real quick and see. So if you were to take 100 divided by 7, so you're looking at 14-degree splits. Let's see. You said the hell would that? So basically, what you'd have 14% between the degrees of cooling is what that would be. So it'd be like 14, 14, 14, 14, 14, 14, 6, 7. So for every, let's see, and then you have, so you have 25, 50, 75. So I think how that would work. I was trying to come up with how they read that 7. Because what you're doing is your proportional band is basically 0 to 100%. And at 25, 50, 75, 100, those are your different stages. So you're taking 100 degrees, 100%, and you're breaking it up into 7 chunks that are 14 degrees apart, 14% apart. Yeah, think about that for a minute. Because you're slowing down your cycling, but you're not really saving any energy.
I'm just
Prevent
doing
short
what I was
cycling.
told.
Yeah.
They're spending big money.
Normally, the way you'd save energy is you up your return air temp. That's how you save energy, not by decreasing the cycling. But let me think about that. Speaking of return air temp, generally on a Liebert, you're just inside the return air rack. That's where that sensor is. So if you were to look at that Liebert, you're standing in front of it. They come mounted inside the return air rack, just inside the filters if it's an upflow. And then if it's a downflow, it's just on the top. So keep that in mind if you're out on a site, and I've seen it before where you have that hot aisle, cold aisle, you're right in between some, and you got a bunch of hot air coming into one side of the unit. It might be missing that sensor. So it's good to know where those sensors live. Same with if they're upflow. They come up with enough cable from the factory that you can move those from one side to the other too. All right, AG is basically the same controller with more functions. Once again, they don't make it anymore. So if you have a customer that has a bunch of Lieberts with a bunch of these advanced graphic type displays, you might mention to them that these aren't made anymore. So either stock up on controls or start having that conversation about getting rid of them, because it'll bite them in the ass eventually. You start losing boards. eBay will only have them for so long. And those are iffy at best. Same thing on the resetting alarms. This kind of walks through it. Generally, if you have an alarm like a temperature, high temperature, low temperature, humidity, those will self-clear once the temperature comes back into range. Somebody mentioned a short cycle alarm.
Yeah.
Is that on a data center with like low load?
Yeah, it was the
Yeah. Does anybody else just turn those off? That's what I do.
I disable the alarm.
Yeah, most of them are always disabled. Just turn those short cycles off. One thing about those short cycles, though, those all DX Lieberts up until the scrolls, the Digi scrolls, they pump down. So when you turn them off, they close the liquid line solenoid, they pump all the gas into the high side, into the receiver, and then they sit there. If that liquid line solenoid is leaking by and it has to constantly pump down, it'll throw a low suction alarm or it'll throw a short cycle alarm. Yeah. So you won't get that if you disable it, but most people just turn them off.
Do that through the programming, or you do that on the board?
On the board.
Switch.
No, on the board.
3, 2, 1.
Yeah, just go into set up alarms. So like on if you were on this one here.
Not touch screen.
Yeah, so like on this one, let's see if it actually has
It's right dead center bottom, set up alarm.
set up alarms.
Mm-hmm.
Yeah, enable alarms right there.
Yeah.
So if you were to go into enable alarms, you'd see short cycle alarm, and you can just turn that on and off. I wish I had a display like we could play with or something, but I don't know how to do that.
What's up with you? Come on, Seth.
Yeah, I know. Well, you guys swap some out, put in some touch screens, and we'll build a
Hey,
chain
you
with the
planted a seed in my head.
Tell Liebert to take one down.
Yeah, there you go. You can buy the touchscreen trainers, but they're freaking expensive. No, what's up with the projector here?
Well, you know what? You could actually sell that stuff because it's cheaper than sending any of us to class.
Yeah, we had that conversation earlier. It's
How'd it go? You need some support?
it's like 10 grand or 12 grand to send a guy.
That's cheaper than sending any of us to class for a week.
Well, no, for the Liebert school.
Yeah, that's what I'm saying,
Yeah.
for the class.
Yeah,
versus
for the
getting
trainer,
tested
the
for
trainer would be
Well, I was
cheaper.
talking to the guy over at Liebert Everett, and he was telling me that they used to hold classes down there, but last year they stopped because there wasn't enough contract paying $1,500 or something like that for us to come sit.
Oh no, they asked McDonald Miller to fill their classroom. They were just going to offer one, and we wouldn't fill their classroom, so they canceled.
Yeah, I was like, that's crazy.
They weren't giving us
we
any,
tried to.
they weren't giving us any cut rates to do it.
No,
They wanted to charge an arm and a leg and less testing.
they wouldn't work with us.
$1,500 a
It
pop.
was more than that.
Well, then you got to pay for the guy while he's off, plus pay his wages. And
Yeah, no kidding.
it adds up, man.
Oh yeah.
Especially if you send him to like Ohio for the 5-day or something. I've never been, but
Oh, he did.
Dirk got to go.
Robin,
Yeah,
yeah,
now they sent him for UW data because that was part of the agreement.
somebody had to be.
They had 40. What did they have? 40 Liebert there.
Jeez. 40 leads. This is the same picture as the last one, so it's the same board, like I said.
Now, are we keep losing that?
It's
the last one you were
this
scrolling
thing's cycling, yeah. That computer's staying on. I don't know what's up with the
Projector.
Good connection.
projector.
So that contact came up there, stuff.
We're almost through the controls, and we'll take a break. I'll screw around with it if it comes back. This is the same board as that AM, so the dip switches are in the same place, and that little wheel's in the same place. Dip switch 8 disables your passwords, and it's the same 1, 2, 3, 3, 2, 1 as the AM.
There it goes again.
Yeah, sweetheart. We can get through the controls and screw
Must
around
be
with
too
it.
high def.
Burning it up.
And it'll be awesome. I can get the other projector out if you want.
Yeah, we might have to. Just not seeing that HDMI. Wiggle this a little bit. See what happens.
Now you gotta reload the whole thing.
What's that?
It's back.
That's bad.
Something happened.
See how long it lasts. Same thing on the resetting. The loss of power, the low suction, and a short cycle would reset automatically, but it takes 90 minutes. Normally, if you walk up to a unit and it's got a low suction alarm, and say like a wire popped off or whatever, off the low pressure switch, you put that back on, it won't automatically reset. You have to kill power after a proper shutdown. The proper shutdown, you remember, off, compressor cycle, fan turns off, and you turn power off. That's how Liebert likes it.
So it's probably reading out the pressure switch on the suction side. If it shuts off and the pressure's too high, it trips that. It's
Yeah.
going to see a lower number.
Wait, say that again?
If it trips on low suction,
Mm-hmm.
if you do it in proper shutdown while it's running, it's probably sensing that pressure of the suction line there.
Yeah.
Knowing that it's too high.
Yeah. Well, then it didn't open the switch because it didn't pump down. And I just put the same thing in here as far as some common settings. So if you're reading through this and we're looking, that's the same graph from before, 72, 10 degree differential or sensitivity, unless your customer's specifying otherwise, some high temperature and low temperature set points there. Oh, it actually kicked us back. I thought we were on that. Okay. So this is the AG, little bigger display. This one's probably 25 years old. It's not made anymore. Little easier to read. Same, you got temperature over here, humidity here, and you'll have unit status over here. If it has an alarm, there'll be a little hammer striking a bell that's up here in the corner. and there's instructions here. We'll go through, you can go through the flow chart and it'll show you status, it'll show you alarms, what's current. Most people have ran through these. If you don't do it often, it's good to refer to this chart. I mean, we could talk about it, but it's better just to look at the chart when you're standing in front of it. And you can see there's a lot more going on here. This is a lot newer control than the old one. There's more options. You can put all sorts of extra sensors in here, these analog sensors. You can actually put in an underfloor water sensing cable layout within that display. So if there's water under the floor, it'll show you where it's at. I've never seen one that did that. Anybody ever seen the on that display?
On the older, which display are we on?
This is the AG, so the little bigger gray one.
Yes.
You've seen it. I've never seen
UW
it.
data, every one of them had it on there.
Really?
And you can tell where the water was by the alarm will show you the point of where the water is.
Under the floor.
Mm-hmm.
That's pretty cool. I've seen it on like the wall displays before. They'll tell you like what foot mark the water's at, and then you have to look at a map and see how that cable's laid out under the floor and where 1,050 feet is or whatever it tells you. But I've never seen it on the display. Yeah, there's just more going on here. Here they actually broke down the alarm setup. So like when we were talking earlier about like short cycle, so here they actually expanded it. So here you could enable or disable short cycle for both compressors.
Also put custom alarms in there.
Yeah, that'd be like water underfloor, smoke, loss of water flow. You could name it. Yeah, it's just a setter. Basically, a power comes out. It's just looking for a dry set of contacts. Then you can label it whatever you want. Same thing. I don't know why it kicked us back earlier, but same thing, same board. Stuff's in the same. So this is that large icon we were talking about. This one's been discontinued too now, and this one's not even that old. I put in a little chart here, kind of help you navigate. But what's important here, if you've ever worked on these things, this control has all sorts of these little symbols: fan, cooling, free cooling, maintenance. Have you guys used this maintenance function within the large icon?
I have not.
It'll record like compressor cycles, fan on time, and it basically gives you a little report on when maintenance is due. Some people use it.
I see more tasking.
Mm-hmm.
Yeah. It's kind of nice for if you're trying to tune it to keep your compressor cycles down. It'll record all that, and then you can change that deadband. So there's kind of some nice things here. We're not going to go through all these. There's just too much. But what's kind of nice about this, it'll show you what these different, let's see if it'll go. You can see how many different options you can have on this display here as far as return temperature, static pressure for under the floor. Like here, okay, this is fan speed, and then this little bar graph, it'll show you how much fan speed you're at. It'll show you 85%. It is a nice display. I liked it more than the touchscreen. This is where we get into the little longer passwords. The user password that most guys use that are working at the data center is this 1490. The service password that most of us use is the 5010. That's a good one to keep in your phone. And then there's an advanced password if you've ever used it. So that's like level 1. This is level 2. And then there's level 3. You guys ever get into level 3?
Yeah.
A little bit. I think I got it right here.
It's 2210.
2210, yeah. That's a good one to keep in your phone too, because you can get a little bit further into the controls. And it's more advanced than this class is getting into, but adjusting like on the DS units, they use ball valves, little BLEMO actuators for controlling head pressure on the water-cooled units, instead of like the old standard water regulating valve that's off head pressure. These ones use transducers.
I do have it.
You had it?
Yeah, I just never use it.
Yeah. You don't have to put the 0 in when you're putting those in. You can just the 0 default. So 501 and 221. Let's see what else we got here. There's instructions for putting the password in, and this would come in handy if you're standing in front of the unit and actually reading through it.
This one's actually one that would be really nice to have it in front of you because there is so much in there to actually put your fingers on it and do it in a class would be.
Yeah, it would be
Worth its
handy.
weight in gold.
Yeah, and that's something that we might look at.
We got that vacant space out there, what's that building up at 217? We just put those crack units in there.
Yeah, but it's not this controller.
It's not this controller,
No,
it's
it's
the
the
other
other one. It's the next one.
Oh, the touchscreen. Yeah, take a field trip over there.
We could.
Got a bus?
Have a bus? I don't have a car.
Need a short bus for this group.
Helmets are required.
Does arc flash gear count?
Arc flash gear. Yeah. There's a whole nother thing. Yeah, I think you're right. I think I just don't know how you do it. Like, you'd almost have to
trainer.
You'd have to do like one at a time, like sit and like just kind of play on it, I guess.
Well, an idea, right? This is a trainer. If you actually took one and had a video of it, and you were basically talking, just like a YouTube, talking on what you're doing and how you're doing it, touch us, basically a video right behind you doing it.
Yeah.
Using your Mac lens.
That's better than that right there, right?
Versus having this in front of you on your iPad and like reading through it while you do it.
I'm just saying for a trainer. I mean, yeah, if we're going to sit through it, I don't need to see you go through it when I'm trying to do it. Then it's easier for me to read it. But if you're having a training class,
Yeah.
for you to take 15 minutes of your class and do a video of a basic setup or changing of an alarm or something like that.
Could do that.
Or quick
That-
videos and we can research them out when we forget.
Well, and that's something that we've talked about a lot of is doing more like
30 seconds.
videos where, yeah, how to clear an alarm or how to change a set point.
Yeah.
It'd be pretty easy to do, especially, yeah, you can use the Mac lens or
Mm-hmm.
whatever.
Now with that right now, we got approval for using the Mac lens in a certain room, which is not hard to do.
Yeah.
I mean, some of them will let you.
Makes it kind of tough. Well, the point here would be, was more, you'd have this on your iPad, and then so you actually go out, and then you have a question, or you need to go through this again.
Right, this is a one-on-one training class, right? I mean, some of us don't necessarily need this, but for a one-on-one class, to actually sit back for a 5-minute video, a 10-minute video, and actually see how it's done. Because, I mean, this guy's great. He's never even seen this.
Yeah.
So for him to pull it up on his iPad, he's not even going to know what to look for,
Right.
versus actually seeing it being done. Dang, the light bulb's going to
Yeah. Okay. I can do that.
just turn out.
If somebody's got a place in mind you think we could do that at, we could schedule a time. I like it.
Not everybody's got clearance. I mean, I've got HP. HP would be great, but they aren't going to let anybody all send. But
The two of us.
they really won't let you video it either. No, they won't let you video it.
Yeah. We'll see what we can come up with. See if we can come up with something. And actually this plays right into your point. One of the things with these large icons and the touch screens, they do what's called teamwork mode, where you'll have multiple units on one display. And you can actually you walk up to a unit and you might be looking at the unit next to it. And we've had guys, and maybe you guys have done it, where you go to turn off the unit in front of you and you end up turning off all the units in the data center. And that's where that video would come in handy, showing how to see, because
It's all the way at the top. It tells you which unit you're on. You can scroll left or right.
yeah, because it talks about it here, but being able to see it would be, yeah, that's a good point. These are some different things that you might see on the display of why the unit's off, alarm off, maybe it's manual off, local off, and kind of a short description. So if you walk up to it and you're wondering why the unit's off, this is kind of help you why it's off. And then there is somewhere here, back, the lights change based on what the unit's doing. Green is on and red is alarm, but there's an amber.
Amber is standby.
Yeah, I think, and then flashing amber
His loss of communication.
Yeah. And that's, oh, here it is right here. You guys can't see it. There you go. That's what it is right there. So when you walk up to them, so the blinking red is active, unacknowledged alarm, solid red, acknowledged alarm, but somebody acknowledged it, but it's still going on. That amber is, there's available, but it's not operating. So yeah, like you said, there'd be like a standby. Green, it's running. And then alternate standby. And then amber, it's just off. Yeah, okay. Let's see here. A lot going on here. Now we get into those EC fans, which I've got very little experience with, but I wanted to put something in here for your guys' reference about how to change them. You can actually configure the fan speeds. So like the minimum fan speed for energy savings. If it's a direct expansion unit, so it's a compressorized unit with transducers, so it knows what the pressures are that it's running at. It'll drop it down to 70%. Chilled water units can go down to 60 from the factory, or optional 25, which I have seen that. So you got a building with a chiller plant, and then all these levers, they'll actually sit and just kind of coast those fans and ramp them up based on demand. Super energy efficient. The DX units with the low pressure switch is 80%, and then if you don't have any type of capacity control, then they don't turn the fans down at all. The large ICOMs, which were on those bigger displays, they do the events, which is kind of nice. It'll show you 300 of the past events, when the unit was turned on, when it was turned off, any alarms that came in. If it switched units, like it was in a teamwork mode, it'll show all those. It's kind of nice for troubleshooting. And then we get into the touch screen. There's actually a video on the touch screen. I wish there was a video on the large icon, but there will be on the next class.
I'm sure there is on YouTube.
No, there's like Jim, the Liebert guy, but you couldn't hear him very well.
In this short video, I'm going to demonstrate the menu structure with the new ICOM unit display. There's a few things that you should know first. First is the menu had some carryover from the original ICOM, so that people that were trained on the original ICOM still have some familiarity with the new ICOM. But a few things have changed. Based on who you're logged in as, whether you're just an end user or a service technician or an engineer from the factory, you'll be presented with different icons across the top. A bigger feature that we've implemented in the new ICOM is based on the unit type. It will organize the sub-menus to only show you the relevant information that is pertinent to that unit type. So for example, if this display is representing a chilled water unit, I'm not going to see information like compressors or reheats if that unit isn't equipped with those components. So you'll see as I'm selecting the user menu and a pull down, a lot of the sub-menus have that same carryover from set points to alarms to display options, and the same as the service menu. So if I move over to the service menu, pull down, you'll see that the sub-menus are very similar to the original icon. Now once I drill down into a menu, what we've done to make this very simple to navigate is we've broken it up into subcomponents in a dual pane setup. So if I want to adjust something underneath my temperature compensation, only the items in the right pane, once that sub-menu selected, apply to temperature compensation. And I can easily adjust those by touching the screen, selecting save, and then hitting my home button again to return to the main screen. The unit will relock if the inactivity of the touchscreen, if no one's touched it for X amount of time, and depending how you set it up, it'll automatically relock, or if you don't want to wait, you can relock it yourself. So that's the basic menu structure for the new icon display.
Something. I think we could do a better job. Same thing with the other one, the lights mean different stuff. And I think actually this guy changes color based on how far out of range you are. So if you walk up to it and this has a nice green temperature, I think you're within range. And then that changes based on how far out you are. Kind of like some building control systems. And then here's a guide for your lights. So if you walk up to the unit, kind of gauge what the different alarms are.
Good news is moving it to our iPhone. Do you know what it's doing before you get there?
What's that?
And then I need to take into this wireless so I can tie into it before I get there.
Not with Liebert. I haven't seen that, no. I've seen some building controls. Iconics can do that.
They have met this over where you don't have to use the keypad. You can hook up to your laptop and do that, so you don't have to go through. I've got a customer that hates that screen, so he's got the cables for Liebert. Just hooks right up to it.
So he walks up to the unit and plugs in and does it on his PC.
Yeah.
That'd be kind of nice. Yeah, and on this one, the codes are the same. There's a direction here for getting into the unlock screen. So this would be the...
Pretty much prompts you.
Yeah. Yeah, it's somewhat intuitive. The codes are the same, the 1490, the 510, the 221, so you can get in and change stuff. I haven't had a lot of experience with the touchscreen, although the times that I used it, it seemed like you could walk through it fairly easy.
Just gotta find it. You go back and forth a couple of times.
Yeah.
Until you figure it out.
Big thing's having passwords and not having somebody not stand over your shoulder with it, wondering what you're doing. There's some screenshots here that I put in. As far as kind of how the menu structure goes. And without having it in front, I mean, it's kind of, no one's going to remember how it goes, but to be able to look at it on the side or maybe before you start playing with the unit, it might be helpful to kind of follow through or be able to see it before you start doing it, but it's just kind of a guide. And this is the event log, similar, just like the large ICOM where it saves the 300 past events. This is the same type of thing. This is kind of an example of, it'll show you it's on the 29th at 1:25, the unit turned on. It was in backdraft mode. This seems like a lot of stuff going on within a couple minutes, but it's kind of the point is you can kind of see what the unit's been doing, what its history is, kind of help you diagnose it. If it was an alarm or not, so you can see here, like there's yellow's a warning, red's an alarm. The difference between, and those are programmable in the settings. A warning is generally just like it sounds. It's something's come up and it just wants to alert you to it, but it's not going to call for help. It's not going to send an alert to the building if it's tied in. Whereas a warning or an alarm will generally call somebody or shut the unit down depending on what's going on. All right, we're going to take a break from there, and then we'll get into some proper operational levers. Do you have a burrito?
I did.
You can send it.
Chicken was good.
Yeah.
Hot sauce. Yeah, hot sauce was good. There's a lot of air in the lips.
Oh, really?
Don't worry, it's all natural. Help yourself.
Natural sugar.
Funky salad, man. Yeah.
Grapefruit.
I like jicama, but I was afraid to try it. What do you throw on coffee? Yeah. Oh, the pink thing. I like it. I thought it was tortilla. It's dry out. Huh. Yeah. All right. Oh, wow.
whatever.
I have no idea. I can see a bunch of editing.
Oh my God. Yeah, at least this weekend.
Yeah.
Some guy out here with a truck with delivery equipment. From our office. Okay.
Yeah, and I want to talk about class. A little bit forward. I saw that there's a calendar out here in town.
Yeah. So air parts and bearing,
Yeah.
motor, you know.
Yeah. That was something I thought about proposing doing was if we could have like scheduled days where there's not even any schedule. Guys,
A lot of the ones we have are old. The first couple of video things that he showed.
Yeah, I haven't.
I love it experience. Okay.
Probably like 8 of those burritos in my van. How long do you think you're gonna keep? Have lunch with it.
I see that thing's still on.
Have you guys been to a Rite Aid yet?
Yeah, 2 of them. Went to one. I think you went to one, and then I went to the next one in St. Helen. What? I spent, it was 2 hours.
You're gonna keep us busy,
going through, and then it took me an hour and a half the first time on the phone. Figured out how they wanted to do the quote process. And then the next one, everything was in specs, and I called them, and they wanted like these exact details of price breakdowns of taxes and drive and labor, and I called up to Seattle and you know what, send it fucking done. Sorry, I told you to play hockey.
You try to post that, or is that just?
Yeah, there's a work. Well,
I tried doing it, and you let me complete it.
Come on, where you go?
It just sent out a number of
Really?
Today?
20-year-old to 25-year-old?
I guess Derek's actually a professional for the
I
radio.
played flagpole.
For
Send
after
it
hours.
to them. I think I made enough of them mad. I don't have to.
I'm just
Don't
gonna
forget
go.
about
That
it,
was
she'll
my
send
goal.
you back.
But
There. I know one building, your equipment's just all
And-
shit.
went to the St. Helens one. That was,
Like I could keep.
The one in Oregon City, Oregon City Shopping Center.
And it's just, I don't know, I can keep playing on
Yeah.
the stuff.
Fuck,
It's
it's
really feel tough.
I used to be a Palin's, that's a whole ass store.
Well, we
One guy, he
sold
tried to go
further
through my slide.
for
I caught the
to
ball,
Rod
and
Payne.
turn around, he's like, oh, it's your perfect time to.
Rod Payne's.
pull the flag.
Showed up
I
there.
look at him,
Atomizer
he looks
won't
like-
work,
like
the
he's about to
belts
wrap me
were all
up.
busted up.
I'm like, oh, no. I just lower the shoulder down.
The compressors was
There we go,
dead.
there comes the bad truck. It's like, sorry, he had that green
I
one.
went to one day, they installed a new unit, but they hadn't installed.
I get,
that's
I
what
would
I
get those penalties. Like the
They asked why you
guard,
didn't
they
do it.
come, Look,
Fix it.
Yeah, brand new unit.
I'm just
Never, doesn't control, it's never been part of it.
I was just using the.
So we opted out to installing
You can pull it out of
contractors
it.
do the controls or?
Well, that's why I didn't touch it. I was like, do you guys wanna have the people who were supposed to do this come out and do it?
Free?
Right?
Because
Well, you already paid for
They
it.
might.
Thank you.
Yeah.
I got an after hours over here at this Integra, and it was on a Sunday, and I showed up, and two brand new Liebers started up by McKinstry on Friday. And they were both down in an errors. I'm like, I know I'm here after hours, but do you really want me to fix this? I mean, they're 2 days old.
Oh, no shit.
Yeah, so they got a whole McKinstry to come out and fix them.
You're probably getting lost, so they drooped down into the.
Talk about,
The upstairs mezzanine
One of
area.
them failed out and the other one was still lit with
Well, you
water.
still got paid.
Yeah,
Hell.
I got paid drive time there, I got paid time to bullshit and tell them, nope, you can't fix it.
All right, teach us something, teach.
All right. We're on the home stretch here.
Don't threaten me.
Yeah, where are we leaving from to get home now? What time is it?
So we're gonna get into some operation. I don't think this will be new to too many of you, but whoa, that picture sucks.
I was hoping you were gonna say that. I didn't want to say anything.
Well, there it cleared up.
I get mine in.
There it cleared up. So this is on the Challenger. Basically, never the same. I mean, Challenger is generally the one-step cooling DX. So you have on or off. It'll kick the unit on at 100% cooling, turn it off at 50. Those generally the Challengers have the hot gas bypass because they're only one stage cooling on and off. They tend to run beyond their set point so that they'll end up getting that evaporator coil really cold.
They overshoot.
Yeah, they'll overshoot a little bit, so they have that hot gas bypass to kind of run the temperature back up on the coil. I've never seen the two-step cooling DX on a Challenger, but apparently there is one that kind of gives you a little more capacity, I guess, or capability. On the, let's see, where is that? These are some standard pressures. I mean, we're just talking R22, so it's nothing weird. But it's good reference for the guy that's maybe never worked on a Challenger or never worked on one of these units. to kind of what you should expect, minimum, maximum for your pressures. Lieberts are designed to carry over a wide range of temperatures, so you can see like here if you're an air unit where you're actually pushing the refrigerant up to the roof, you may have 15 pounds of suction and be considered within normal range according to Liebert. I mean, that's really low, but it may be okay. And you may see up to 90. So that's huge. I mean, it doesn't really sound right to most of us, but according to Liebert, that can be normal. That lead temp, which we're going to get into here in just a little bit, they're made for lower temperature, lower ambience. So it's not going to let it drop quite that much, but the rest of them look a little more normal. 20 is pretty low. What's that? And then there's a discharge pressures. Those look pretty normal, except for, to me, this seems a little high, 330. But this was straight off of that Liebert. This is right out of one of the Liebert manuals. So according to them, with an air-cooled design pressure is 260.
That's 22.
That's 22. Yeah. That's straight out of the Liebert manual. To me, this would be more normal, 210, 225, with your water-cooled.
Especially water-cooled.
Yeah.
It's a kill compressor.
Yeah. But according to Liebert, I mean, that's where it's at. I mean, you're going to hit, there's your high-pressure cutout, so. There's some instructions there. Adjusting expansion valves is nothing new to most of us. Lieberts, you do it from time to time. The Challengers are pretty easy because they're accessible. You're still looking for your same superheat like you would on most units, 10 to 15 degrees, just like any other expansion valve. Counterclockwise lowers the superheat, clockwise increases the superheat. This is a lead temp unit here. And there's a receiver on the side, there's a heater blanket in the bottom, and then it has these two little sight glasses. I couldn't get a colored picture, but if anybody has one of these and wants to send me one, I'll put it up here. But those are those instructions for figuring out charge on those things. So if you walk up, and it's all based on outside air temp. So if you're looking at it, an outside air temp's 40 degrees or lower, it should be midway on the bottom of the sight glass. 40 to 60, bottom sight glass should be clear, and 60 and above, midway on the top. So as your outside air temp increases, your liquid level increases. Kind of counterintuitive. You'd almost think it would go the other way because you're pushing more liquid. But yeah, it's flooding that receiver. I haven't seen a lot of those leak temps. When you do see them, they're on shorter buildings.
It's like a headmaster.
Yeah.
I have one.
I've seen them not like that. It's like the smaller condenser units where that tube's actually standing up. It's not laying sideways.
The what? Oh, the receiver?
Yeah.
Really? I've never seen that one.
Where the hell have I seen those? I've seen them in Seattle a lot, actually. The north end.
There's a piping diagram coming up here, and exactly what Brett just said for head pressure. We'll go over that. A lot of times on Lieberts, you'll see a little lower evap split because they're doing so much more of that sensible cooling. You're not trying not to pull moisture out of the air so much. A lot of times you'll see them around 15 degrees, and your subcooling is generally 10 to 15 degrees. Chilled water Lieberts, one thing to note on those, while they're super easy to work on, the only thing you're really checking on is discharge air temperature. That's all there is. You're just a valve. You're just opening and closing chilled water. So generally you'll track somewhere close to the water temperature. So if the water temp's 50 degrees coming in, your temp's generally somewhere around 55, something like that. But there's not a lot to see on them. The R22 DS3s, those are the bigger ones. The 25, 50, 75, and 100%. Like we talked about, those have the two 06D compressors normally. Sometimes they'll be the Copeland discus. Does anybody have the Copeland discus compressors? They don't seem like they're that common. Normally it's the green Carlisles. They'll be unloaded when they start. One compressor runs unloaded, then both compressors run unloaded, then one loads up, and then the other loads up. it's just a way to try to keep those compressors on more instead of cycling on and off. It tries to run them, keep one compressor on instead of turning on and off all the time. Equipment likes to run. Deluxe System 3s are a lot like the Challengers. There's some standard pressures for an R22 unit. Pretty much the same thing. That's Liebert recommendations on your suction pressure, minimums and maximums, and then same with your head pressure with your discharge pressures.
Information of why it would be as low as 15, or in between, or as high as 90.
No, but that's something I could research a little bit more.
Well, because honestly, I'll get calls from guys going, "Hey, I just replaced this compressor and my suction pressure is 72 degrees and we're close to space temperature. Why is my suction pressure so high?"
72 psi.
Yeah. That's sort of normal.
Yeah, no, because 68 would be 40 degrees saturation.
Right. It's like, well,
I think it's, well, because I think what they're saying here, this would be like maybe if you're running really cold return air temperatures. I mean, really cold.
That's just extreme.
When you're at the 65 degrees.
Yeah. I don't know how they came up with that number.
Yeah. That's what I was wondering if there was something that would give you a why it would be.
Why you'd be 20 degrees or
Yeah,
20
20
psi.
psi.
Yeah.
Yeah.
Because then you're, I mean, that's got to be like 10.
pressure, isn't it?
It's damn close.
It's
damn close. Yeah. Probably 10. I think it goes through it here in just a minute.
I think maybe you're running your remote condenser way across the other side of the building.
Let's see. Yeah, so on those lead temps, the lead temp consists of a modulating head pressure control valve. So kind of what Brett had mentioned there. Here's a piping diagram on that. Let's see, does this have the lead temp? Oh, this is hot gas. So this is if you're running a really cold evaporator. It'll help. This is that hot gas bypass here. There's a solenoid that opens up when the unit runs, and then there's a hot gas valve, and it's dumping that hot gas from your compressor discharge into your evaporator to help keep that evaporator temperature up so it doesn't freeze. Yeah, it just keeps it from freezing under really low loads. You don't see them a lot on the Deluxe System 3s, but they do have them. And then the lead temp, these are the ones that are good down to negative 30 here, and I think there's a piping diagram coming up here. Where is it? Yeah, it's coming up. So this is the Econocoil. This is the free cooling coil. Liebert also calls it Glycool. The name's kind of interchangeable. If you're connected to a building water loop, or you're connected to a closed loop where it goes up to like a dry cooler up on a roof, if that water gets cool enough, it'll open up a valve, we showed the picture earlier, and flood that coil to provide some free cooling. So when that happens, it actually looks at that temperature, and what it looks at here is the glycol capacity first becomes available when the entering glycol temperature is at least 8 degrees below return air temp. So if you're 8 degrees below return air, it'll open up that valve because it sees that there's some cooling that's going to take place. Or if you're 3 degrees below for 2 hours. Now what's kind of weird about that is 3 degrees isn't that much. And what'll happen is, if you look, it'll take the proportional band and double it, and I'll show you what that looks like here. Let's see. So what it'll do is it'll take, instead of being like 0% to 100% and having your stages in between of cooling, quarter capacity, half capacity, 75, based on room temp, it doubles it. So it says the first part is done by water, and then the second part's done by DX. And it'll calculate it based on return temp. So if it's 8 degrees below room temperature, it calculates that at 22% capacity. So it gets kind of weird. What I've noticed, I don't know if you guys have these, but if you have a building with condenser water that they tend to get cold during the winter, Liebert's kind of act up and you start getting really weird water or room temperatures, fluctuations in the room. Has anybody noticed that or have any buildings with these systems? Because it's trying, like it says, it's trying to calculate. It's trying to calculate this, how much capacity it has based on water temperature coming in for free cooling.
So at 22% capacity, you're basically running one compressor unloaded.
Right.
So
that's kind of, yeah, that's kind of what it is. So keep that in mind. If, when you go into winter, if you have a data center that's connected to with Glycool, with these Econocoils, if you get a complaint or you get a service call of the data center temperature is fluctuating, generally it's based on the outside air temperature, and it's because of this. It's doing these calculations. It gets kind of funky. But one thing that it does say is if you have water that's 25 degrees below the room air temp, that's considered 100% capacity cooling. So that's kind of your range there, is 8 to 25 degrees. That's where you get those funky room temperatures. Does that make any sense?
Yeah, I mean, you think about it, well, let's see, 25 degrees below. If your ambient temperature is 75, you're on 50-degree water.
If your room temp's 75, yeah. So that's generally a chilled water loop is 50 degrees.
Right.
So yeah, that I've noticed that a bunch where I've disabled this on some units during these shoulder periods, like we're in now. We're warm during the day, but we're cool at night, because the Lieberts are constantly trying to calculate how much cooling that they can get out of that water, and the rooms tend to kind of fluctuate based on it.
Now, you can't get in there and actually adjust any of the PID loop on these, though.
Not on
the older two.
Not on the older. On the newer ones, you can go in and tell it at what temperature to turn on and off. But you can't control like the PID loop on the water side. No. Those valves are proportional. They can go from 0 to 100%, just like any water valve. And then the fans can drive between the minimum and the maximum based on load. It gets pretty complicated, but they save a lot of energy. They do a good job. We're going to watch a short video on these Digiscrolls. Does anybody have a Digiscroll? Anybody heard these things? How noisy they are? It basically sounds like your house heat pump going into defrost, but it does it constantly. So we're going to watch this real quick, and we'll kind of go over their operation.
Deluxe System 3 to make it a Liebert DS. I think the IT managers are looking for what will grow with their room. There's a rapid change in data centers today. Servers last a matter of months before they're replaced. And so IT managers want cooling equipment that's going to grow with them and be very reliable so that they don't have to worry about their cooling solution. The flexibility of Liebert DS is probably best seen in the digital scroll compressor. The digital scroll compressor adapts to changing loads. So an IT manager brings in this equipment today. The compressor modulates the load today. When the IT manager brings in new servers, they'll probably be higher density. The Liebert DS will automatically modulate up to that new capacity. Liebert DS has several features that increase availability. The digital scroll compressor is designed not to cycle. Compressor cycling is what really leads to wear and tear on the compressor and causes it to fail. The digital scroll compressor is on almost all the time, so you don't have compressor cycling. We've done a lot of work on the blower system, a 5-year belt, 200,000 hour bearings, and that really increases the availability of that system. I think what makes Liebert DS a good investment is the longevity. We expect the product to last 10, 15, 20 years, depending on how well it's maintained.
10 years seems kind of short, doesn't
The
it?
energy efficiency of the digital scroll compressor
Just got a warranty.
Yeah. To pay back that
But the belt's got a 5-year warranty.
These belts are awesome.
Liebert DS has several energy efficiency features. The visual scroll compressor operates more efficiently when it's unloaded. A lot of data center cooling is oversized for future loads. And so the Liebert DS will modulate to the right capacity, and that's more energy efficient. The compressor runs more efficiently at those levels. There are many energy standards going into place today that require even higher efficiency requirements. The Liebert DS is designed with such flexibility that we can actually mix and match the components to create even higher efficiency models towards tomorrow's energy efficiency requirements. Federal legislation is phasing out a lot of today's refrigerants. And so in the future, green refrigerants will be required. Liebert DS is already designed with a green refrigerant as a standard feature.
That one's going out.
Yeah, no.
7C. I was surprised when I heard that.
Compressor is a great feature with many good benefits from digital scroll. The ability to adapt to changing loads in the data center makes it a nice option. The fact that the compressor doesn't cycle improves its reliability. And then the compressor operates more energy efficiently when it's unloaded. The ICOM control contributes to energy efficiency because when the units are networked together, they don't fight each other. And certainly, a unit that's reheating in one side of the room, another unit that's cooling at the other side of the room, is not very energy efficient. ICOM eliminates that trouble. When the units are networked together, it increases the reliability because you can have standby units that will come on if there's a failure in the system. With over 40 years of design experience, Emerson Network Power to design a product that's very energy efficient, very reliable, and very flexible. That's what IT managers are looking for today.
Alright. So those DigiScrolls, they're super noisy. When they first get put in, everybody calls and says this compressor is eating itself up. They sound horrible, but they work well. Either they're 100% or they're 0%. So the way that works, and I'll try to explain it, but they basically operate on a 15-second duty cycle. So if the compressor runs loaded for 15 seconds, that's considered 100% capacity. If it runs for, like in this case, it runs loaded for 10 seconds and then unloaded for the next 5, that's 66% capacity. If it ran for 7.5 seconds, say that it was loaded for 7.5 and then unloaded for 7.5, that would be 50% capacity. So that's how Liebert runs their product. So what that means is if you're anything less than 100%, you're going to have a load and unload every 15 seconds. And if you have 2 compressors, which they all do, that's 4 loads and unloads every 15 seconds. That's a lot of, and every time it does it, it like somebody said, goes burr, burr, and it like shakes almost. Like it's freaking ridiculous, man. And it causes a lot of service calls. They eventually get used to it. Luckily, data centers are generally kind of noisy. But yeah, that's how they work. So if you walk up to one and you're wondering why it's making that much noise, this is what it is. It's that 15-second modulation cycle, and then it starts over. You can't run them at 0% for more than 15 seconds because like any hermetic compressor, as everybody knows, that's how they get cooling. You got to be able to bring back gas to cool the windings. So you have to keep them at 10% or above.
Well, they got that liquid head injection, right? Oh, cool them.
Not on these ones. No, not on these ones. So like these, you can have them at a minimum of 1.5 seconds de-energized, which de-energizes loaded. The solenoid's de-energized, so it's not bypassing. So you get 1.5 seconds de-energized, and then the remaining 13.5 seconds energized. So yeah, they're funky, but they do work well.
Jose, it does have to do with that. That unit, FEI, the noisy one, is that the safe compressor?
Yep.
That's
Those
why
are
they
the
have-
CRVs. I don't know if you've seen those CRVs.
What's the CRV?
That's what the Liebert.
It's a Liebert, so it's a unit that fits inside the racks.
Oh, yeah.
Yeah.
I've never worked on one,
We have a
but
pair
yeah.
of those, and good install, bad application.
One of those, huh?
Yeah. The noise, of course, one is actually noisier than the other, so it's probably cycling based on where it's at. It's probably by this. It's probably cycling off and on, causing that excess noise. But the biggest thing is their return air has to be 85 to 90 degrees.
Yes,
That's their-
hot, so it's really need a hot air, cold air there.
Yeah.
You have in there.
You have to have the cold dial, hot dial on that.
Mhm.
So, anyway, okay.
Who else has been called out on that one?
it yet.
Yeah, so I was betting that's what it was.
That's the service.
That's the one I got turned back around now?
Yes, it is.
Wonderful.
The very same one.
Yeah, and Aon uses those too. And there's other companies that use them. And sometimes you'll see you'll have like a standard scroll that's not modulating or digiscroll, and they'll have a digiscroll next to it. So it'll do like digiscroll from 0 to 50%, and then the other one comes back on, and the digiscroll shuts off. And then from 50 to 100, then the digiscroll kicks back on. And
I
takes
might
that
have
a
that
little
set
bit.
up in a Daikin package unit.
Yeah, Daikin does it
30
too.
ton package.
Yeah, they're not Copeland's, but they do the same thing with the Daikin compressors. Instead of running two, variable speed compressors, which makes sense. But yeah, these things are noisy, man. Yep. The 407, it's really comparable to 22 on its pressures, and here's another little guide for what you could expect on discharge. Same 210, 225, upwards of up to 330 on the max.
You guys have that a lot in Seattle? See that 407 see a lot of it?
Yeah. Yeah, it's fairly common.
All the new ones are putting in a 407.
That one. Oh, so this was, I don't know why you can't see it, but on all these not all of them, but most of the DSs and all of them with digiscrolls, instead of having a manual head pressure control with a capillary tube that goes over the discharge and that regulates water flow, they all use these ball valves. So you'll see those if you ever work on them, and you can adjust through the controls, head pressure and timing and some stuff. Just something to be aware of. They work really well. So one thing about this 407C, it is a blend, and we're going to start seeing more blends as time goes on. You guys aren't already working on equipment. 410's a blend. They're going to be more and more common. And one thing with the blends, there's two things to be concerned with. One is leaks. Because it's a blend, they tend to leak different parts at different times. And there's a lot of controversy as far as how many times you can top off a system that's had a leak. Because if it leaks out, you don't know what leaked out. One kind of general rule is if you leak in a heat exchanger, they're going to leak in different unequal parts because there's two phases there. A heat exchanger would be like your condenser and your evaporator. So there's part liquid and part gas. So if your leak is in that, you're going to lose more of one refrigerant than the other. Whereas if you're in a liquid line or a suction line, those are all either full liquid or full gas. So you're going to lose equal parts of each. So if you get a leak on one of these units with a blend and it's in a suction line, you don't have to think about topping it off because you know it leaked out in equal parts. You can just top it off. Same with liquid line. But if it leaked out in like the evaporator, it's questionable. And as you lose more of one type of gas, pressures change and things won't add up. So if you go out on a unit that had a leak, pressures and temperatures don't make sense. There's a good possibility that it leaked out more of one refrigerant than the other. And like on 407C, you can see here it's a blend of 32, 125, and 134. That's why it's going away, is because 134A is going away. And that's what it is. It's a blend. One thing with these blends, they tend to have what's called a glide. Single part refrigerants like 22, 12, 502, they, when you look at a saturation or a boiling point, it basically, there's no difference. Like as soon as it starts to boil, it starts to boil. It all boils. The whole column of liquid boils. On these, they boil at different parts, and you end up with what's called a glide. And that glide, like on 407C, the glide is between 8 and 12 degrees. So if it boils, say at 200 psi, you'd have to look at your TP chart. But if it boils at 200 psi at 100 degrees, only part of it's going to start to boil. And then as you raise that temp up another 8 to 12, the rest of it's going to boil off. Well, that same thing's happening in your condenser and your evaporator. So you end up with two different charts. You end up with a bubble chart and a dew point chart. Have you guys seen those two charts on gases?
When you're boiling now.
Yeah. Yeah, exactly. So like subcooling, you base it on a bubble point, and superheat, you base it on a dew point. So I think the next one here, like with 407C, that thing clears up.
Should be able to pull it up on your phone.
You can pull it up on your phone too, the Bitzer chart. RSD has a decent one. Oh, you can't see that with the oh, there it goes. So like this one here, it says this chart is only used for superheat, for operation and superheat. Discharge, hot gas, and suction gas. So that's all you use it for. So if you're taking a superheat, you use this chart. Versus if you're going to take a subcooling, which that's how you would take a reading for with something with an expansion valve, right? You take your subcooling, you'd use this chart. And that's going to be more common as we move on, as we get into these blends more and more. 407C's got a pretty big glide, 8 to 12, but there's some of them that have even more. So it's going to be more and more critical that you make sure that you use the proper chart when you're taking your readings. There's a little blurb about 407C, and it was originally developed to replace 502. That's not really important. All right.
So it's HP80.
HP80,
Yeah,
that 410?
404.
Oh, that's 404.
502. When they went away with all the R12 and 502, they came out with shit tons of refrigerants with glides off the chart.
I didn't think 404A was going to go away. It's still so cheap. So this is a standard Liebert wiring diagram.
It hasn't changed in 40 years. That's the nice thing about it.
That's the nice thing.
Yeah.
So for the newbies that never really looked at a Liebert wiring diagram, what's really nice about these is they have numbers up and down the side, and then all the everything in this chart is in a line item here, and it has a number next to it. So like if you're looking for, say you're looking for the main fan triac, or we'll just look here because the arrow's pointing at it, the econocycle triac. It says it's on line, what is that, 44?
64 or 48.
I think it says 44.
You got 44.
44.
That's a compressor trial.
No, it's 48.
Yeah, 48. Oh yeah, conocycle triac. Okay, 48.
My bifocals.
This is just this is an example. That could be liquid line solenoid, or it could be up here like main. Maybe here's a better example. Main. Oh, it just got better. Look at that. Main fan contactor, line 14. So if you're trying to figure out where that's at, you look over here and you can see that there's numbers here along the side. See if we can get that thing. So you'd look along the side and you say, okay, line, there's 10 and there's 15, so there's 14. So you follow that over and you'll find what you're looking for. Oh, shit. I guess I can do that. See if we can find it here. Line 14.
Right there.
Right where?
What are you looking for? Is that right?
Main fan contactor.
Directly below you.
Below me. I see the.
That's on line 14.
That's to the right.
Is that
Main
MF right there?
contactor coil.
MF right there.
MF, yes, the coil.
To your right, to your right, to your right, to your right.
Oh yeah,
Main
main fan
fan.
right there. There you go. Yeah, that's pretty
That
simple, huh?
motherfucker's main fan. Right there, I gotta push the motherfucker.
Yeah. So that's how you find stuff on a Liebert wiring diagram. They actually make it fairly simple. A lot of times, if you don't know that, if you don't know the numbers.
You put the codes on there, now everybody's gonna know.
They just need to make it bigger.
1, 2, 3.
Yeah.
3, 2, 1. It's written right on there, man.
Oh, it is. Somebody wrote it right on there, didn't they?
Good
there. That's funny. This is, somebody sent me this picture. Oh yeah, they put them both on there. That's awesome. Yeah, so that's all there is to the diagrams. These I've always really liked Liebert wiring diagrams. They're well laid out and they're easy to find stuff. I don't know if they're better than Aeon's, but they're pretty good. All right, so we're going to get into some operation and maintenance of the specific components. I know talking to Sean, he had mentioned air side economizers as being something that he was running into. I've never seen an air side economizer on a Liebert. I've seen the water side plenty, but have you seen many of these, Sean?
No, no, not many.
Yeah, so I threw it in there just as kind of a reference. There's some information as far as it's just like any economizer. Everybody should know what economizer does. If the outside air is suitable for cooling, it opens up the damper, pulls it in, alleviates some of the useful mechanical cooling. This box would have return air would be one side, outside air would be another. That'd be on opposing linkages, either one actuator that opposes or two actuators that drive in opposite directions. One opens up, one closes, just like anything. So I don't know how much we'll get out of this, but one thing that it does say to do is if you install this damper assembly, and here's kind of a picture. I'm guessing that'll clear up a little bit. This is an airflow sensor that will tell the unit if if the damper fails, and it sucks closed. There's instructions here for adjusting this thing. So if you end up walking up on one of these things and you're having intermittent failures of an airflow switch or fan fail, this might be a good reference on how to adjust that thing.
What are the set points you're looking for?
We'd have to read through it. You talking for the set point of the switch or
the switch?
Well, let's go through it.
Right down at the bottom, half a turn for standard cooling is about 75% airflow.
Yeah, it looks like
Yours are better than mine.
No, my contacts are better.
your contacts are better. So it says turn on the unit must be running.
5A.
Oh, I see now.
What'd you see?
5A.
Third line from the bottom.
That's just one of the adjustments on it.
Oh,
Just what it.
yeah, it looks like
Internal.
turn on the unit, turn the restricted airflow switch alarm set point knob clockwise until it trips, and make sure it alarms, and then turn it a half turn for standard units. So you go back a half turn, and one full turn for units equipped with variable frequency drive. So it kind of depends on what you're running there.
Application.
Yeah. Do you have any of these? Do you know of them? No.
I've never seen it.
Yeah,
They're rare because most data centers don't want humidity in there. So
yeah, they don't want the opening to the outside air. Yeah, I'm with you.
Skip over that, huh?
Yeah, exactly. Well, one thing to note here, though, that might come in the future is this: what they do run on. They run on either 0 to 10 or 2 to 10. So if you were to replace an actuator or something, or go out to one that's not working, if somebody was out before you and put something up that was like per milliamp, knowing that it's 2 to 10 or 0 to 10, that's something. Yeah. The minimum on the return air on these is always going to be 15%. That's like we talked about earlier. The return air is where the temperature is sensed on Liebert's from default. So they're not going to close off that return air damper because they want to keep some airflow across that sensor. So if somebody was to set up these things improperly and close off that return air 100%, that would throw off the controls, probably cause short cycling of some kind. Let's see, I'll just skip over that. Talks about basically economizer setup. If you bring in outside air, you have to have a way to relieve it. And then, what do we got here? This is kind of basic economizer diagram as far as outside air coming in, return air being mixed in through your mixing box of the unit. You'd have an outside air damper here, mix it and bring it in. Generally, these things will try to keep this supply air, the mix of the two above dew point, generally around 55 degrees. If it was 10 degrees outside, you're not going to dump 10 degrees air into a space, so you're going to mix these two. That's just basic economizer theory. All right, humidifiers. So everybody's seen these. This is what's called an infrared humidifier. There's a little closer up version of it, and this is it flipped upside down. What these do is there's a water bath. This pan has water in it right here, and then this is the lamps that sit above it. And those lamps turn on. They're super bright. There's 3 of them. They're halogen, and they basically kind of boil that surface water, and that's how they put moisture into the air. Any air conditioner, especially DX, that's running a coil that's cold, is going to take some moisture out of the air. And so you have to put some of that moisture back. So that's why these things have humidifiers. To me, this is the most common, this infrared style. They work really well. They're either on or they're off. There's a little closer view of it. The way they work is there's a makeup water solenoid here, and there's a tube that runs across. You can kind of see it right there. And at the far end, it just dumps into this pan, and it fills this pan with water. And right here behind the wiring, you can kind of see it. There's a standpipe. It's connected to a drain. That standpipe sits up about yay high. It's a little bit below the lip of this pan. So when it fills up, the water runs down that standpipe. And that's how they kind of keep themselves clean, as they overflow that pan, and it carries the minerals down the drain. This switch here, this is an overflow switch. It's not a fill switch. It's all based on timing, is how these things fill. It knows how long it takes to fill it based on water pressure. It assumes 1 gallon per minute as a minimum, and it just fills based on time. The controls know that those lamps will boil a certain amount of water every minute, and it refills it based on that. And we'll get into the calculations here a little bit.
Please pull that stem.
That stem?
Please twist and pull that out once in a while to clean out that pan, and it also makes sure that tests your pump. Mm-hmm. It also tests your piping to make sure that you don't have any leaks in it. Because no shit, as soon as you leave, there's going to be a problem with your humidifier. So I mean, that's a must do on a maintenance.
And it's super easy on the downflows that have those pans. They're right in front. I'll show that picture again.
That little strainer in there too is good to pull out.
On the makeup valve?
Yeah.
Yep. So this is that unit flipped upside down. The lamps. There's 3 lamps here. They sit in these little ceramic holders. They just turn on. They're super bright. Most people, the way they test them is they push the humidifier contactor in, and you can see the reflection of the water. You can see those 3 lamps, so you can see if they're burned out.
It's tough to see. I always amp them because.
You should always amp them.
Because if there's only 2 lit, it's still gonna be so damn bright, you're not gonna see.
Yeah, you're right, you should amp them. Generally, it's about.
You should get about 13 amps.
Yeah, you should get about 13 amps on all 3 legs. Let me go back here.
And those things are a pain in the ass. Bulbs.
Dude,
Yeah.
yes.
Those bulbs are a pain in the ass.
Yes, they are a pain in the ass.
And they're easy. I just did it today. It just,
Did you replace the ceramics? The blocks?
I will be. No, I don't.
Yeah.
Normally don't have to.
Really?
Yeah.
I always had trouble with the little terminal strips.
Yeah.
You replaced the
Wires
strips
you
in,
gotta
right?
fish through and.
No?
You know, the slot heads didn't
Yep.
come
Well,
out?
that's
They didn't weld in there?
Oh, I've been lucky. I've only had to do it, a couple of times.
Oh, man.
A lot, but.
So like Sean said, this standpipe right here, it's basically just a short piece of pipe with 2 O-rings on the bottom, and it fits in a little socket, a little cup.
Pup. We call them pup.
Pup?
Yeah, it's pup.
Pup. So you can just grab it. If it's hot, you can grab a pair of channel locks, pop it out of there. If the water's not hot, you can grab it with your fingers, twist it out, let the water drain down. These things, depending on your water quality, you might have to clean them once a year. You just pull that pan out. Like Sean said, you take the standpipe out, drain the water out, take that pan over to a mop sink, scrape it out with whatever.
And it slides right out. It's easy.
Yeah, it's fairly easy. There's a union of some kind to the drain here, so you can take that apart.
I have that snap ring style hose clamp on it.
Yeah.
Like it says here, the lamps do not touch the water. They sit above the water. They just boil the surface.
Unless they're broken.
If they're broken, so in my experience, I put this in my experience, you can get about 20,000 hours out of these lamps. If you push it much more than that, they start burning out, and eventually they'll drip down. They'll melt into the water and blow the fuses. So if you can all the displays will track hours. So if you're on top of your maintenance, try to change those out at or before 20,000 hours, and you'll be good. These things are 100% on or 0% on. They're just on or off. There's no in between. The way that they keep themselves clean is in the Liebert auto flush. So it basically overflows the pan, and it's counting on the minerals floating on the surface and then going down that standpipe. You can adjust how often or how much water goes down the drain. The factory default is this 110%. What that means is it's going to add 10% more water than it calculates as necessary. So 100% would be it only adds exactly the amount of water that it calculates it's going to boil. So at 10% over, it's going to flush 10% down. I normally set these things at 200%, so it uses double the amount of water that it needs, and it generally keeps them pretty clean. What you're dealing with these is mineral deposits. It's not slime, it's crust.
You'll see it on them.
Yep.
It's usually all over.
If the water quality is poor, you might have to bump that up even more. I'm sure everybody's kind of got their own numbers that they've figured out on these things. They work well. If you have it's pretty rare that you get a call for low humidity, but a couple things with these, if you have a lamp out, if the standpipe, that one of those O-rings or both of them are missing and water's just flowing down the drain, it can't get hot enough to boil. Or if you have a stuck solenoid valve that's constantly dumping water in, then you can't get a chance to boil it. Those are about the only real issues that you have with them. There's a picture of the float. So this is normal operation. This is how you put them back in. I get this call about once every 3 months from somebody.
They had to put it in upside down.
Yeah. So what that is, it triggers a humidifier failure alarm. It's basically telling the unit that it's overflowed because somebody put it in upside down. That's not how it goes. Because remember,
option.
Huh? The float?
Yeah.
Well, on the early controls it was. So you might have a unit without the floats, yeah. They were
It was in the instruction manual, it says this is an option.
Was it an old unit?
88.
Yeah.
cleaning the pan, just like we talked about. I mean, you turn it off. Their procedure is to remove the call. So you remove the call for humidification. So you go into the controls and turn that humidity setting down and let that water cool down. Leave the fan on, let it cool down, and then just start taking it apart. Pull the pan out, scrape it out with a scraper, push it. They're not too difficult, and it's pretty self-explanatory. And put it all back together.
Change one bulb, change them all, right?
Oh yeah, never just do one bulb. If you if you have a bulb out, yeah, that's a good point. They're kind of a bitch. Those ones that the down flows, the pan's right in front of you. But on the upflows, the pan's in the back. And if you ever have to do one with the pan in the back, you're kind of hating life at the end of the day. Because you're laying on those condenser barrels, the shell and tube heat exchangers. They're kind of a pain. Like, you'll feel it at the end of the day, laying on that filter rack. So this is another option. These are the humidifier steam cans. There's this style here, and then there's another picture. There's the horizontal. Same basic principle. It's a plastic cylinder with rods that go into the water and boils the water. And I found this kind of a nice little video on how they work.
Yeah, that's the bottom connection.
Contact CP3, a new generation of electrode steam humidifier.
CP3, oh.
Continuous operation builds up mineral deposits, even on the electrodes. Of course, such incrustation decreases conductivity. The controller automatically recognizes this buildup of scale. It reacts by increasing the water level to cover unused electrode surfaces. Therefore, the required steam production is not interrupted.
So it started kind of late. I don't know why it started that late, but the way these things work is these are three-phase. So there's L1, L2, and L3, and these rods extend down most of the way to the bottom of that cylinder. As it fills, the water level comes up and it starts to contact these rods. And depending on the conductivity of the water, it starts to pass electricity through the water and it boils it. That's kind of, I don't know why it skipped over that part. But then it basically, as it boils that waterway, these rods start to get coated. And that's what he's talking about there.
Even on the electrodes. Of course, such incrustation decreases conductivity. The controller automatically recognizes this buildup of scale. It reacts by increasing the water level to cover unused electrode surfaces. Therefore, the required steam production is not interrupted. But continuous operation causes this previously uncovered part of the electrode to fur up as well. The water level is raised again. The result is twofold: increased operating life for the cylinder and the assurance of long-term and maintenance-free operation. Once the electrodes are completely insulated, the level detector sends a maintenance message to the control card. The maintenance message is automatically transferred to a monitoring room via
Awfully dramatic.
And you can, there's standalone humidifiers like what they're showing out there.
I like their video. So like I said, those ones, what's nice is you just pop them out at the end of their life. The Liebert will throw a signal for failed humidifier problem. There's a board in there. I couldn't get a good picture of it, but there's a humidifier board with a light, and it'll tail flash and tell you expired cylinder. Those ones you just, if it's this style here, which to me this style is a little more rare on the Lieberts, but they're real popular in like Data Airs.
Especially Data Airs. I think that's the only one I've ever seen in there.
Yeah. On these ones, it's real important when you change these out. These cylinders, this is like a standard, like a Nortec 511 or something. It'll come in a cardboard box, and there'll be an O-ring in there with it. That O-ring is there for a reason. And what that is this is a drain right here, this part on the bottom. down here, that O-ring goes down in here. So when you take this cylinder, you lift it off of there because the cylinder's bad. You look down inside of this thing, and there's an O-ring. That's where that goes. You pop out the old one, and you push in the new one.
I've seen those solenoids fail due to moisture down the area with leaking water lines.
Oh yeah.
They're a bitch to replace.
We always add salt to that water, or should we measure in the water to see the conductivity of it?
No, you're better off just dropping in a teaspoon of salt.
Yeah, half a McDonald's packet. Yeah. So
That's technical.
yeah, technical.
A
So-
McDonald's milli-
If you have one that has that little drain valve, that picture that I showed, you should be pulling that out every time and taking this thing apart. Inside of there, there's this little sleeve, a spring, and a plunger. These things get gunked up, and what will happen is they won't close off all the way, and then the cylinders constantly fill because they can't maintain water level. But yeah, on the let me see here.
They're showing it lifting off the cylinder right there on the left.
Yeah, there's that drain valve there. So, like Sean said, these are more common in data errors or standalone units, but Liebert has used them in the past. But they're simple to maintain. You just pop them off, pull that drain assembly out, clean it, and put it back together. And then I put a little blurb in here about the salt. Let's see here. Where did that go? Did anybody see it? Basically what happens is we have really soft water in the Northwest, meaning there's not a lot of minerals. It has low conductivity. So when it fills up, it hits those rods, but it doesn't see the amp draw that it wants. So it fills up more, and it fills up more, and eventually it hits the high water sensor, and it thinks it's expired. And then it throws a flag up or throws an alarm that says replace the cylinder, but it's brand new. So you know it doesn't need to be replaced. So that's where throwing some salt in there helps.
I just do it out of habit.
Yeah, I always did too.
Go up just a little bit more. I think it's enough to get to that mineral laden it said.
But that's the reason for it, is just because we have soft water. If you ever been to somebody's house on a well, some wells have really hard water where there's a lot of mineral. That would be highly conductive water, but most of our city water isn't like that. I've always found like a half a McDonald's packet, like McDonald's packets have those two little tubes of salt. You just tear off that one side, just dump it in the cylinder when you're replacing it. That's enough. If you put too much in there, they'll arc and they cause problems. So you don't want to put too much
Cool to
salt
see
in.
though.
It's cool to see in a dark room. Yeah. Oh, here we go. You're in a soft water area like the Northwest. You need to jumpstart the steam process, half a McDonald's packet. Then you can check the amp draw after installation. It starts off at about 0. So you put your amp meter on your humidifier contactor, and it'll be at 0. And then as that water level comes up and it starts passing, you'll start to see your amp draw rise up. What's that?
Is it really responsible for everything?
Yeah.
But you figured that out after the safe driving course.
Electric heaters, we normally don't use a lot of electric heating in data centers. The only exception might be if you're doing like dehumidifying, because then you'll run heat and you run DX at the same time, so you're not cooling things off. So I didn't really put much in there for the electric heat, but it's just electric heat. One thing of note, if you're new on a data center maintenance, don't go testing your electric heat function unless you know that they've been on a bunch. That happens every few years. We'll get a guy who goes into a data center and turns the heat on or pushes in that contactor, and then it sets off the smoke alarms or the halon, worst case.
No,
That's how we put it in test.
This one in the worst to cheat.
Yeah, don't throw it right in the test and run those heaters. Refrigerant side, Lieberts, Challengers, any of them, they generally run with a full sight glass when charged. Liebert's, they'll show up with just, if you lose a pound of gas, you'll start to get bubbles in them because they're so small. Whereas the bigger Deluxe System 3s, they can lose up to 5 pounds and still have a full column. Although you will get some diminished operational capacity. So if you have a Liebert that's customers complaining about saying it's not cooling as well, just because it has a full side glass doesn't mean that it may have a full charge. Oil level, generally let them run for a little bit and then check it on like the Carlisles, the semi-hermetics that have an oil sight glass. Should normally be 1/4 to 3/4 up the sight glass. If it's low, that means it went somewhere. So try to figure out where it went before you just start dumping oil in. It's not that easy of a process, so it's not like you're going to dump some in generally, but try to find the leak or figure out if it's logging somewhere in the evaporator or somewhere else. The hermetic scrolls, you're not going to have a sight glass of any kind on those. I've found in my experience that it's pretty common for those Carlisles to leak out of the belly pan a little bit, and that's not a big deal. You don't get any refrigerant out of them, but it's pretty common to get some oil out of the bottom of those things. It's normally just a few drips, but if it's the top compressor, then it drips onto the bottom one, and it can be kind of deceiving and sometimes look kind of messy. Try to keep those cleaned up. Belts, Challengers, and the Deluxe units, just like anything, check them often. 1/2 inch to 1 inch of movement is pretty common on those. Everybody's familiar with belt maintenance and not over tightening belts.
Is that the only one, that new brand that's coming out, is that the only one that has those 5-year belts on it?
Yeah, so the Deluxe System 3s, which I think we get right into right up here. They come with here it is right here, Deluxe System, the DS units. They come with a self-tensioning motor base, and that's this guy right here. There's instructions for setting it up right here. They're really simple. There's basically a bolt down there that has connected to a spring. You set the tension one time and you leave it for 5 years. I've got one that's been going since 2008, and I've never replaced a belt. I never tightened it. Those Liebert belts are really good. They're made specifically for Liebert. They're low dust, they're long life, they work really well. The self-tensioning motor mounts are awesome. So if you got a maintenance with these DS units and they have that self-tensioning motor mount and Liebert belts, don't be replacing those with the crappy standard Opti belts or Gates belts or DX or DX belts or something. Try to stick with the Liebert belts, and they don't need to be done every year. Unless the foreman has something different to say about it.
Do I have anything different to say about it? No, the hard part about what you just said is when a customer's paying for belts to be replaced, what do you do with them?
It'd have to be a change to an as needed.
Yeah.
That'd be my suggestion. They're a great setup though, man. The pulleys are big enough. They work really well. Really well. Liebert blower bearings, they're lubricated for life. Generally, they don't have any zerks. Sometimes you'll find them that somebody put zerks into. The newer ones are all built for 200,000 hours of lifespan. So the only thing is checking the set screws on the collars. You don't have to lube them. They do recommend on the motors to replace them after 5 years. You have to grease them after 5 years. So those will have zerks. So keep that in mind if you've been tracking it, you've had the maintenance. After 5 years, you should be greasing the motor, but you won't be greasing the pellet blocks. Yeah, it says that in the manual too. And then one thing I found, somewhere around 2008, 2009, when the first DS units came out, they had speed drives but no shaft grounding protection, and the bearings start making noise. Liebert has a shaft grounding kit available. They're the Aegis rings, if you're familiar with those. They sell a kit. It has a conductive epoxy and a split ring that goes on the shaft end of the motor. You clean up that end bell, you glue that ring onto it, and it helps helps pull that current out of the shaft so it doesn't go through the bearings. That's kind of a whole nother class, but I would rather see somebody use the cool blue.
When is that class anyway?
Well, it was going to be next month. Actually, no, it is going to be next month because I just scheduled the guy yesterday. Northwest Motors. They're the rep for Cool Blue.
Do you have a brochure that I can start giving out?
It's all in the Dropbox. You can print it out.
Okay.
Yeah. Well, I'll show you where it's at.
Yeah, the email you sent, right?
Yeah. It's got all that in it.
Yeah, I'm sure which one of those you want me to send to the customer.
All of it there in the price sheet, probably. Yeah. Because our prices. We get prices.
Obviously, I was going to ask before I.
Yeah. Yeah, we can go through that too.
You want? I'll see if it's fine.
There's a lot of information, but yeah, he's not scheduled for Portland. They're gonna do a class in Seattle and they're gonna do a class here. I just don't have this one scheduled yet. It'll probably be like mid December, I think. We'll look at it after this. When that is. Some common alarms with Lieberts, high head pressure, somebody turns off the water, plug coils, standard things. On Lieberts, if you're standing on the end with the Deluxe System 3, you got the 2 compressors. Here's where your head pressure switch is at, and there's that little tab that sticks up right there. That's the reset. Once you're reset, the compressor would restart and it self-clears. And then just like anything, why would you go off on high head? Well, you're not transferring heat, so figure out why you're not transferring heat. Close valve, plug coil. Right next to the high head pressure switch lives the low pressure switch. That's right here. Low pressure suction alarms. Those are generally caused by lack of refrigerant, a leak. They have these little tiny capillary tubes that come out of the bottom of the switches. Those tend to rub together and create leaks. It could also be that low temperature switch that we saw on a slide a while back on the end of the coil. If you had an Econo coil, if that DX starts to freeze up, it'll throw a low suction pressure. Loss of airflow is a fairly common alarm. There's a pressure switch in there that monitors return and suction airflow on the filter and the discharge air. And it's just making sure that the fan's started. So if you have a broken belt or plugged filters or one of those tubes fell off of that airflow switch, that can throw a loss of airflow. Loss of power, that's if you lost power while the unit was running. You didn't do a proper shutdown. Say the data center went into an alarm, they lost power, or they did a monthly test. That's a fairly common one, that loss of power. Humidifier problems, infrared. The only real alarm you get is high water. That's that float lifting up. There's no other alarm for humidifier, so that'd be a plug drain, improperly installed float. That's basically about it on those. Steam generating canister, that would be if it hit high water. That's what that is. If it filled up that canister all the way and hit the high water sensor, that'd be your replaced canister alarm. Low temperature, those are field selectable. Those are ones that you would put in or a data center manager would put in for monitoring temperature. Those are self-resetting. Low temperature, short cycle, we kind of talked about those. If a unit cycles 5 times in 10 minutes on the low pressure switch during non-cooling, so that means that it's sitting there in standby, it's waiting to run, it's pumped down, but for some reason it keeps kicking on and trying to repump down. Generally that's a liquid line solenoid leading by, or valves, discharge valves leaking back through the compressor. You'll also,
That's a little bigger problem.
yeah, it's a little bit bigger problem. That's the next class. Or if you're getting 10 starts in an hour, so every 6 minutes, that would be a short cycle. A lot of guys just turn those off, especially if you have a data center that's under low load. Liebert doesn't have a way to like disable one compressor. You can't just turn one off and make a 30 ton, a 15 ton, or a 20 ton, a 10 ton. There's no correct way to do it. So they end up starting, they ramp up to full speed, and then they shut back down on when there's a low load, and you end up flagging with these. It's really hard on the units. But until they get load, there's not a lot you can do. Let's see. Low suction. Common issues, refrigerant leaks. It's just like anything. Check the tubing. Check the routing of the piping coming out of the compressors. Just make sure things aren't rubbing. They have vibration.
There's a lot of vibration.
Yeah, they have vibration just like any compressor. There's a lot going on in these things. They tend to pack that piping in pretty tight against the frame of the units. So make sure that their clamps are in place. Things are there or come from the factory to hold the piping. So make sure that those are where they're supposed to be and not broken.
Yeah, I've seen a few of those clamps break too.
Yep, they vibrate out. Another common thing is the compressors have these brass fittings where the high and low pressure switches connect. And if you get a rebuilt Liebert or a rebuilt compressor, they tend to use that blue goop sealant on those threads, and that blue stuff doesn't work all that well. It's drying up and leaking. So you'll start seeing oil and refrigerant coming out of those fittings on the compressor. So check those brass fittings. And then condensate leaks, just like anything, any DX unit that removes moisture, you can have condensate leaks, plug drains. The older units use these cheap white plastic T fittings down inside the condensate lines, and they tended to get brittle and break. You can get those through your Liebert rep. That's a big source of leaks. A lot of guys will replace them with copper. They'll make something up, or brass. Liebert did come out with some stronger black plastic T fittings that go on those condensate lines. Yeah, and slime buildup. That's pretty big on these Lieberts, but it seems year to year is what I've noticed. Some years they don't build up as much slime in the condensate as others. So if you're doing a good maintenance, try to pull all those condensate lines out of the unit and flush them out, kick all that slime out so you don't get plugged. What's that? Hand tabs.
I do actually.
Hand tabs help.
The way I do mine is I actually drain my pan all the way down, my humidifier pan all the way down, and I'll throw 4 or 5 in there. It's an additive. It's going to help, and it's going to sit inside the trap, right? Because those are all trapped underneath there.
But a lot of the slime comes up above that, though, out of the condensate pan, and then it comes down to the T. That's where you're flushing. So between the T and where it connects to the pan is where you got right at that nipple up in there.
Well, you should have
barbed fitting.
Yeah, you should have barbed fitting.
Hand tabs as well.
Yeah, you should.
Yeah.
And it helps somewhat.
Yeah, I mean, I only put like 4 or 5 in there. I'm not going to dump the whole deal, but just 9 times out of 10, there's still a little bit left in there by the next maintenance, where you can see the residue that they are being used. So,
yeah.
Yes, I do use pan tab.
Yeah. Oh, I'm a big advocate of them too. But you'll still get some slime.
Yeah.
Factory support. Liebert has really good tech support. That number should be in everybody's phone for Liebert factory tech support. When you call it, it'll prompt you. It'll ask you for, is it air side? Is it controls? They take you to different people. They're really easy to talk to, and they'll generally stick with you as long as you need.
Don't be afraid if you don't like your answer to call back.
Yeah. Sometimes you get one you like more.
Is it that
You might actually find one that knows something.
Is that a distributor off Carbon?
What's that?
They're off of 72nd.
Yeah, by Carbon Drive up by that Chevron.
No.
Because there's one right over there.
Emerson?
Yeah.
In Seattle, it's Bob Todd. Been there forever. Down here, it's John. John's a nice guy if you haven't met him.
Yeah.
He's been around a long time.
I found it's easier to email him. He can get back to you faster.
If you have John's email, yeah, email him. I don't have it, but
Tom Preston here, if you don't have it, he can give it to you like that.
yeah. Yeah, don't be afraid to reach out to those guys. Both of them have been there forever. I heard Bob's retiring. John's probably not too far behind him. But they're good resources. They can provide some light tech support. They're really good with parts and parts numbers. you guys will have copies of this whole thing, and then you'd have this link. This will take you to the Liebert site where there are some manuals and some things. But I'm going to show you, unless anybody needs a break, I was going to show you the Dropbox, and we'll basically be done.
Okay. And that's where this information is going to reside.
Yep, I'm going to show you exactly where it's at.
I was just looking, I looked at the Trello for that class, and I didn't see it.
We can go through that too. The cool blue?
Yeah.
Well, it's labeled Motors 101, and then look in the description. I'll show you that too.
What's it under?
Are you in Trello?
I'm in Trello. Technical training. Oh, M&M training ideas.
Oh no, you're in the university. You need to be in the schedule.
Oh, there's a job.
Here, I'll just go right to that.